Hey guys, welcome to my channel. When you think of infrastructure in the United States, the first things that probably come to mind are the iconic orange-red cables of the Golden Gate Bridge or the endless stream of cars on the interstate highways. These are, without a doubt, symbols of American pride. After all, the Golden Gate Bridge was completed in 1937, and the Hoover Dam stunned the world way back in the 1930s. But today, let's shift our focus halfway across the globe, to China. There, a groundbreaking infrastructure revolution is unfolding, one that is redefining the scale, the speed, and the technological limits of what we once called engineering marvels. This is the story of China's infrastructure, a story of breathtaking ambition and record-breaking projects, of a nation reshaping its landscape at lightning speed and rewriting the global playbook for what infrastructure can achieve. Can you believe this? While America is still stuck in endless debates, just to renovate a single bridge, China has already built the tallest bridge on Earth, suspended between cliffs as high as a 200-story skyscraper. While American high-speed rail proposals are still stuck in Congress, China's bullet trains are racing at 421 kilometers per hour across a staggering 40,000 kilometers of high-speed rail, more than the rest of the entire world combined. This isn't a sci-fi movie. This is real. This is China, redefining what's possible in engineering, one mega project at a time. To be honest, when it comes to infrastructure, the gap between China and the US might be far bigger than you think. Take high-speed rail, for example. America's first high-speed rail project, the California High-Speed Rail, was approved back in 2008. And the result? 16 years later, it's still not finished. The original budget of $33 billion has ballooned to over $128 billion.
So we're here to talk about the California High-Speed Rail Project. So when originally conceived, the voters of California voted in Proposition 1A that they would have a high-speed rail from LA to San Francisco. It was going to be done by 2020, and it was going to cost $33 billion. And people were excited, they were thrilled, take people off the road, out of the air, put them on rail, move them quickly. It was an exciting time, exciting promises for an exciting project. Where are we today? Well, today, we are severely, no pun intended, off track. And that project, thus far, is going to cost the California taxpayer and the federal taxpayer, at best estimates, $33 to $35 billion. At best, that portion of the project is not going to be completed until 2033, 2035, way after this whole project was to be completed. And with the $15.7 billion already invested in a project that has given you bridges here to my left and to my right, bridges to nowhere, right? But this project, if completed, 400 miles from LA to San Francisco, at best, it'll cost $106 billion. Now, most people will say that is a rosy estimate. There's no way it's going to be completed for $106 billion, which, just to do some simple math, that's 3 times.
Meanwhile, in China, since the Beijing-Tianjin line opened in 2008, China has built over 40,000 kilometers of high-speed rail, enough to circle the Earth at the equator, and then some. And the kicker? China's average construction cost is only 1/5 of California's high-speed rail project. It's like China is riding a rocket while the US is still on a bicycle. From the frozen highlands of the north to sun-drenched tropical shores, China's vast high-speed rail network keeps racing forward day in and day out. Now let's talk bridges. Sure, the Golden Gate Bridge is iconic, but today, 42% of US bridges are past their intended service life, causing an estimated $110 billion in economic losses every year due to aging and deterioration. In contrast, China is home to 8 of the 10 longest sea-crossing bridges in the world. And the construction efficiency? Absolutely staggering. In the US, building a standard bridge can take 7 to 10 years. But in China, advanced pivot technology has made it possible for a 16,300-ton bridge to rotate 180 degrees and connect in just 90 minutes. In 2019, the Huajang Bridge in Hebei completed its pivot in only 85 minutes, a new world record. One American viewer even joked, "Do people in China have more hours in a day than we do?" So where does this massive gap come from? It boils down to fundamentally different approaches to infrastructure. In the US, projects often get stuck in endless rounds of approvals, local opposition, and political tug-of-war over funding. But in China, centralized planning and powerful execution enable the country to rally national resources for major challenges. Just look at the Hong Kong-Zhuhai-Macau Bridge. More than 1,400 companies and tens of thousands of engineers work together on a single goal. That kind of nationwide coordination is nearly impossible to replicate in the US. And yet, in the face of what many consider a modern engineering miracle, some voices online from the US have raised doubts. With China's current level of industrial development, can this bridge really hold up? I bet it'll need a full overhaul in just a few years. It can't compare to Brooklyn Bridge, USA. This is just a showpiece, no real use. Just trying to flex on the world stage. A waste of money, purely symbolic, with no real benefit to the region. But these dismissive comments reveal less about the bridge and far more about their own comprehension limits. They conveniently ignore the 1,000-plus patented technologies developed during the construction. They overlook the 6.7-kilometer undersea immersed tunnel, built with a precision tolerance of less than 5 millimeters. And they're unaware of the bridge's advanced design, with multi-layered anti-corrosion systems, seismic resilience, and the ability to withstand Category 16 typhoons, magnitude 8 earthquakes, and even a 300,000-ton ship collision. When Chinese engineers declared a 120-year design lifespan, it wasn't a marketing slogan. It was backed by hard data, rigorous testing, and world-class engineering. These unfounded criticisms aren't just about the bridge. They're about the growing unease of watching China's engineering capabilities rise with a speed and confidence the world didn't expect.
Oh, God, please, no! No!
Imagine this. Beneath the roaring waves of the Lingdingyang Strait, 33 massive immersed tunnel segments, each as tall as an 8-story building and weighing 80,000 tons, had to be aligned and joined together with Lego-like precision. The margin of error? No more than 5 centimeters. The difficulty? Comparable to threading a needle through a moving aircraft carrier during a hurricane. This was the hell-level challenge Chinese engineers faced while building the Hong Kong-Zhuhai-Macau Bridge. John Smith, a member of the American Society of Civil Engineers, once said, "Achieving millimeter-level precision in deep-sea immersed tube joints, we used to think that was impossible in the real world." Faced with such skepticism, even ridicule from overseas experts, Chinese engineers responded with quiet determination. Yes, the difficulty is unprecedented. Millimeter-level tolerance in these conditions is an enormous challenge, but that's exactly why we must do it. This is our responsibility as Chinese engineers. We will not be intimidated by mockery or doubt, and no technological blockade can stop our progress. We will stay on site, research day and night, and even if we fail thousands of times, we will never give up. And they didn't. Through relentless effort, they invented a technique called composite foundation treatment, injecting special materials into the seabed to turn soft silt into rock-solid support, capable of holding tens of thousands of tons. During testing, engineers worked 72 hours non-stop, failed 137 times, until they finally achieved a 300% increase in load-bearing capacity. On May 2, 2017, during the connection of tunnel segments E29 and E30, a sudden tidal surge knocked them 3 centimeters off alignment. In that critical moment, China's self-developed dynamic hydraulic adjustment system kicked in, and within just 15 minutes performed a millimeter-level correction. This move didn't just save the project. It rewrote the rules of sea-crossing tunnel construction worldwide. Today, the 55-kilometer-long Hong Kong-Zhuhai-Macau Bridge is not only the longest sea-crossing bridge in the world, it's a bold symbol of China's engineering prowess. Next, let's talk about water engineering. The Hoover Dam was once a global icon of industrial might, its power output unmatched for decades. But today, China's Baihatan Hydropower Station has taken center stage. Its network of underground chambers stretches over 217 kilometers. That's the length of 300 Empire State Buildings stacked end to end. The largest cavern is 438 meter long, 34 meter wide, and 88.7 meter tall, hence can easily accommodate 13 Boeing 737 aircrafts. And in terms of output, it generates 3 times the electricity of Hoover Dam. Even more astonishing, while America's Big Dig in Boston went 220% over budget and suffered decades of delays, China built Beijing Daxing International Airport, a massive starfish-shaped megastructure, in just 4 years. It handles 200,000 passengers a day and secured 60 international patents in the process. From cross-sea bridges to hydropower giants, from high-speed rail networks to clean energy megabases, Chinese engineers are pushing boundaries again and again, turning the impossible into reality. They are building, quite literally, the backbone of a nation's rise. These projects show that China doesn't just export infrastructure, it exports a complete development solution. Even the New York Times admitted, Chinese infrastructure is reshaping the global economic order. So how is China defining the next century of human progress? While the US is still fixing highways from the last century, China is already exploring the ultimate future of infrastructure. Have you ever wondered how China, once a nation struggling to rebuild, transformed in just a few decades into the undisputed powerhouse of global infrastructure? The answer lies not in slogans, but in steel, concrete, and the unstoppable ambition of a rising nation. Known as the infrastructure maniac, China has stunned the world with mega projects that push the boundaries of what's possible, crafting its own legend with each new build. And make no mistake, the world is watching China's rise very closely. Even the United States, with all its pride and power, has started to feel the pressure. President Donald Trump once publicly admitted, "We can't compete with China's infrastructure."
I love China. People say, oh, you don't like China. No, I love them. But their leaders are much smarter than our leaders. And we can't sustain ourselves. China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
Why? Because many of the marvels China has created, America simply doesn't have the means or political will to replicate. Chinese engineers don't back down from challenges. They carve roads through mountains, raise bridges over rivers, and overcome obstacles with relentless determination. But just how advanced is China's infrastructure capability? And what kinds of cutting-edge technologies are driving these projects behind the scenes? As one of the world's largest developing nations, China has used infrastructure as a powerful engine for economic growth. And at the heart of it all are Chinese engineers, modern-day heroes who are quietly reshaping the world. From undersea tunnels to the tallest bridges on Earth, from expressways carved through deserts to ultra-long-distance power transmission grids, each project is a testament to what human engineering can achieve when ambition meets precision. These projects are not just massive in scale. They showcase China's world-leading capabilities in structural design, smart construction, and sustainable technology. Now let's explore these jaw-dropping mega projects and see how China is redefining what's possible in the world of infrastructure. So why has China earned the nickname infrastructure maniac from the West? It's simple. When the funding is in place, Chinese construction teams can deliver incredible speed without compromising on quality. In contrast, many foreign teams look helpless when compared to China's pace. Take New Zealand, for example. They've been trying to build a mere 300-meter subway tunnel beneath a city center, and after 4 years, it's still unfinished. Now imagine if this project were handed to a Chinese construction team. Not only would 300 meters be done in no time, even 3,000 meters could be completed within 2 years. But of course, there will always be skeptics. Some may ask, if China's construction capabilities are truly that advanced, then why did a Chinese-built office building collapse during the Thailand earthquake? Doesn't that prove it was just another shoddy project? But here's the truth. Isolated incidents like that are the exception, not the rule. Across the globe, Chinese-built infrastructure is renowned for its quality and resilience. Real engineering power isn't judged by one rare failure. It's proven by the countless megastructures that continue to stand tall year after year. Let's look at a stunning example. In Changsha, China, engineers built a 57-story skyscraper in just 19 days. This high-rise was constructed using a modular building block method, where prefabricated sections were assembled on-site at incredible speed. Each module was precisely manufactured in factories, allowing rapid on-site assembly while maintaining outstanding structural integrity and safety. It's a true testament to the legendary China speed and technological excellence. The skyscraper is called Mini Sky City, standing at 200 meters tall with a total floor area of 180,000 square meters, capable of hosting thousands of people for work and living. What's truly astonishing is that this tower wasn't built using traditional brick-and-mortar methods. Instead, it employed modular construction technology. The entire structure was divided into 2,736 modular units, 90% of which were prefabricated in a factory before being transported to the site. On-site, these modules were assembled like giant building blocks, achieving a record-breaking pace of 3 floors per day at peak efficiency. This factory fabrication plus on-site assembly model not only dramatically boosted construction speed, but also ensured remarkable precision and quality. In terms of safety, Mini Sky City was designed to withstand magnitude 9 earthquakes and meets fire protection standards far beyond conventional building. Additionally, the method greatly reduced energy consumption and construction waste, earning it global recognition as a blueprint for the future of urban development. This astonishing achievement once again demonstrates to the world what China's speed and China ingenuity truly mean. While others are still questioning, China continues to push the boundaries of human civilization with one engineering marvel after another. In Africa, the Chinese-built Mombasa-Nairobi Railway revolutionized transportation in Kenya, connecting cities that had never been linked by rail before. The deep friendship between China and Kenya continues to flourish to this very day. Thanks in part to the Mombasa-Nairobi Railway, communication between the two nations has gotten even closer.
Yeah, with the Chinese experience, they've built the Tibet Railway, they've built long railway lines, passing through the parks. And when they build this, they take into consideration the needs for preserving the environment. Yeah, that experience is important in the African context.
I think most of the challenges you're able to overcome. If you're determined to get something, you will get something. Nature has just a way of opening doors for people who are really determined in life.
This can make me to tell my children, and I'll give birth to kids one time in my lifetime. I'll be telling them about me working with the standard gauge railway, what I used to do here, and they'll be happy that their mom once did something nice in Kenya.
Meaning of the bridge basically is linking this group of people to the other group of people. So as you understand this group of people, the Chinese, and I understand my countrymen, then I connect in terms of language, in terms of way of thinking.
Why is China so eager to spend massive amounts of money on helping Africa with infrastructure development? Some find it puzzling, even questioning whether deeper motives lie beneath China's grand efforts.
Been very concerned lately about China. They're in Africa. They're lending money to countries to build ports and different infrastructure.
To build what?
Port,
And
harbors.
what's wrong with that?
And, well, because...
Countries that need ports get ports.
But they're making people dependent on... I mean, I know, it's the same thing that we've done, which is
No, it's not.
horrible around the world.
They are far more humanistic than the United States ever was.
Really? Okay.
Absolutely.
Great.
Let me give you an example. Of course, they are peddling for influence.
Yeah.
Yeah. But they are non-interventionist. Absolutely non-interventionist in a way that Europeans, the West, has never managed to fathom. The Chinese never asked Apple to go to Shenzhen and produce all the iPhones. It was Steve Jobs that decided that. Yeah? Mm-hmm. It was not China that went to Washington, D.C. and demanded that they buy a third of your national debt. If they hadn't bought it, you would be in serious trouble. When it comes to the influence of China outside its borders, it's quite remarkable that they don't seem to have any military ambitions. Instead of going into Africa with troops, colonially, destroying the country, killing people like the West has done for the last 100 years, what they did was they went to Addis Ababa and they said to the government, we can see you have problems with your infrastructure. We would like to build some new airports.
In the Middle East, China's work on the Khalifa port in the UAE and metro systems in Saudi Arabia redefined construction expectations with record speed and unmatched precision. In Southeast Asia, the Jakarta-Bandung high-speed railway stunned the world. Designed, built, and now operated with Chinese expertise, it marks a major milestone in global high-speed rail development. This project stands as a flagship of China's Belt and Road Initiative, backed heavily by Chinese state-owned giants. It is operated through a powerful joint venture between Indonesian state-owned enterprises and leading Chinese railway companies. Initially projected to cost under $5 billion USD and opened by 2019, the plan was soon derailed. Construction hurdles and the shock of the COVID-19 pandemic sent costs soaring past $7 billion. Now, the Indonesian government is pushing forward, aiming to extend the 142-kilometer rail line even further. A train running on the Jakarta-Bandung high-speed railway has reached a speed of 350 kilometers per hour for the very first time during a test run. This milestone marks a major achievement. The railway has officially met its design speed standard and successfully completed the interim goals of dynamic testing, which began on May 22nd. Over the past month, the inspection train gradually accelerated, moving from 180 kilometers per hour to 350 kilometers per hour. Now all functionality, performance, and barrier system indicators of the HSR have met the required design standards, paving the way for future trial operations and the official launch of service. In upcoming tests, the train is expected to reach speeds of up to 603 kilometers per hour. This high-speed line, a landmark project under China's Belt and Road Initiative, connects Indonesia's capital city, Jakarta, to another major city, Bandung. Once fully operational, the railway will slash travel time between Jakarta and Bandung from over 3 hours to just around 40 minutes. This is far more than a railway. It's the embodiment of speed, the hallmark of innovation, and a testament to engineering brilliance. Moreover, it marks a crucial milestone in China's infrastructure going global. So if we want to judge the true level of Chinese infrastructure, we should look at the projects still running strong, still serving millions, rather than magnify the outliers. Why are foreign teams so slow? One major reason is the 6-hour workday culture. Workers clock out on time, no overtime, no exceptions. Half the time is spent chatting, the other half actually working, leaving perhaps 3 hours of true productivity per day. And then there's the pampering. Too sunny? No work. Raining? No work either. Harsh weather? Take the day off. With that kind of mindset, how can projects possibly move forward? In contrast, Chinese construction crews are famously efficient. In China, if a skyscraper takes more than 2 years to complete, it's considered delayed. Next, let's shift our focus to a completed mega project in China. Not just a transportation hub, but what many call the largest high-speed railway station in Asia, Xiong'an Station. This is not just a train station. This is a 60,000-ton steel masterpiece, a mega project where high-speed rail meets futuristic architecture, built not just to transport people, but to showcase the future of infrastructure. Construction began in December 2018, completed by December 2020. In just 2 years, China completed what the world thought was impossible. China's incredible engineering doesn't stop at building cities. It also extends to the movement of water on a national scale. While southern China has abundant water, the north faces chronic shortages. To solve this imbalance, China launched the most ambitious water transfer project in human history, the South to North Water Diversion. With a staggering $120 billion investment, this project spans over 14,000 kilometers, equivalent to building a waterway from Beijing to Egypt. The central route alone crosses the Yellow River and the rugged Taihang Mountains, posing extreme engineering challenges. Hundreds of pumping stations, reservoirs, and tunnels had to be built. And to protect the water source, nearly 400,000 people were relocated. Today, over 10 billion cubic meters of water flow northward each year, bringing vital supply to Beijing, Tianjin, and beyond. This is not just an engineering feat, it's a national lifeline. The South to North Water Diversion Project is the world's largest interbasin water diversion project. It has the world's largest aqueduct system. Transporting water from up high, the longest of them reaches 9 kilometers in one stretch, so that it is not affected by the surface environment. It employs the world's largest pump station group. Designed in 13 cascades, the pump stations lift water stepwise and send water from Yangzhou all the way to the southern bank of the Yellow River. Numerous water interchanges high and low are built. Some cross the Yellow River beneath its riverbed. Some stride the Huajang River from above. Major rivers that are vastly apart now meet with each other. Thanks to the automated facilities that equip the entire route, this grand project is able to navigate through 8 provinces and a major river basins, diverting water over 2,000 kilometers cumulatively in an orderly manner. 9 years into its full operation, water sufficient to fill up the entire Yellow River has been diverted to North China, meaning that 170 million people in 44 cities now use water from the Yangtze River. Today, empowered by modern technologies, China are reshaping rivers like never before, and even create new rivers on this very ancient land. Beyond water, China is now tackling some of the harshest terrain on Earth with the construction of the Sichuan-Tibet Railway, a mega project across glaciers, earthquake zones, and towering mountains. This 1,959-kilometer railway links Chengdu and Sichuan to Lhasa in Tibet. It crosses 14 active fault lines and numerous snow-covered peaks. Engineers face extreme altitudes, frigid temperatures, avalanches, landslides, and earthquakes, all in one project. Some sections exceed 4,000 meters above sea level. Building a single tunnel can take 5 years or more, but once complete, this railway will cut travel time from 36 hours to just under 13. It's more than a transportation line. It's a symbol of China's determination to push the limits of engineering. And the world is watching as this miracle unfolds. From high-speed rail to massive expressways, China seems to complete a mega project almost every day. Just 30 years ago, China had 0 miles of expressways. Today, it boasts the world's longest highway and high-speed rail networks, leaving the US far behind. This is why Chinese infrastructure continues to stun the world. A rare combination of speed, precision, and sheer scale, redefining what modern construction is capable of. Deep in the mountains of Guizhou, a new giant has risen, the Huajang Canyon Bridge. Before even opening to traffic, it faced one of the most extreme load tests in the world. 96 heavy trucks, weighing a total of 3,700 tons, were driven onto the bridge, while over 400 sensors monitored every stress point, deformation, and vibration in real time. And the result? It passed flawlessly. In doing so, it didn't just prove its safety, it rewrote the global standards for bridge monitoring and structural resilience. This isn't just a bridge, it's a statement, a declaration that the center of the world's engineering miracles is shifting to the east. So, what makes this bridge a true symbol of 21st century infrastructure? China is leading a once-in-a-century infrastructure revolution, building record-breaking mega projects at an astonishing pace. The nation's high-speed rail network now extends over 26,000 kilometers, connecting Beijing, Shanghai, Shenzhen, and Chengdu. It has become a global symbol of modernization and efficiency while laying the foundation for long-term economic growth. In 2023, China's investment in infrastructure reached $2.44 trillion, a 6% increase from the previous year, demonstrating its strategy of using infrastructure as the core engine for economic expansion and global integration. These massive investments not only expand global supply chains, but also create opportunities for technological collaboration and innovation, strengthening China's position on the world stage. One of the most striking examples is the Huajang Canyon Bridge in Guizhou Province, an area once divided by rugged mountains. Scheduled to open in September 2025, the bridge stretches 9,480 feet in total length, with a main span of 4,660 feet, reducing the travel time across the canyon from 70 minutes to just 90 seconds. The Huajang Canyon Bridge is not only a transportation link, but also integrates features like a glass walkway, bungee jumping, paragliding, and cliffside trails, making it a new tourist landmark comparable to the Golden Gate Bridge in San Francisco. Completed in just 3 years, this project showcases China's breathtaking construction speed, its ability to overcome extreme geographic challenges, and its growing strength as a global leader in modern infrastructure. The Huajang Canyon Bridge is not only another milestone in the history of Chinese bridge engineering, but also a pinnacle achievement in the field of suspension bridges worldwide. On the map of Guizhou Province, you can hardly find any large flatlands. About 92.5% of the province is covered by mountains and hills, containing 1.258 million individual peaks, cut apart by 8 major rivers and countless tributaries that carve the land into bottomless gorges. Building an expressway across such terrain almost means confronting the very folds of the earth head-on. The Huajang Canyon, located between Liupanshui and Changshinan in Guizhou, serves as a crucial section of the Lian Expressway. To open this route, engineers face 2 choices: either avoid the canyon by detouring over the mountaintops, resulting in a smoother alignment but at an enormous cost, or lower the bridge height by adding more tunnels and steep slopes, making construction far more complex and dangerous. In the end, they chose the most extreme solution: to leap directly across the Huajang Canyon in a single span at an altitude of 625 meters. At such an extraordinary height and span, ordinary bridge types, such as steel girder bridges, arch bridges, or cable-stayed bridges, were no longer feasible. There was only one answer left: a super long-span suspension bridge. The Huajang Canyon Bridge has a total length of 2.89 kilometers, a main span of 1,420 meters, main towers rising 262 meters tall, and a bridge deck standing 625 meters above the canyon floor. It officially surpasses the Beipanjiang Bridge, becoming the highest bridge deck in the world. Upon completion, it will cut the travel time across the canyon from 70 minutes to just 90 seconds. But how do you build a bridge that holds the world's highest deck in one of the longest spans? In theory, it sounds simple. 3 steps. First, build 2 strong towers, then install 2 secure main cables and anchor them firmly. And finally, hang the bridge deck using vertical suspenders. Just like that, a suspension bridge is born. Of course, in reality, it's not that simple. To make the 262-meter-tall bridge towers stand firmly atop the mountains, engineers first had to find rock-solid ground, then drive 24 massive concrete piles deep into the bedrock. How deep? The deepest reaches 68 meters, about the height of a 20-story building. Above ground, each tower, more than 200 meters tall, was divided into over 40 segments. Using a hydraulic climbing formwork system, engineers poured and lifted each segment continuously, allowing the tower to grow upward at an astonishing rate of 0.8 meters per day. At the same time, they poured an enormous concrete anchor block, roughly half the size of Beijing's National Stadium. Why so huge? Because only with its 400,000-ton self-weight could it securely hold the 2 main cables, which would later bear the entire weight of the bridge deck. This is known as a gravity anchor. On the opposite side of the canyon, however, there wasn't enough space for such a massive structure. So engineers used the mountain itself as the anchor, embedding the cable deep inside a specially excavated tunnel, creating what's called a tunnel anchor. With both towers and anchors complete, it was time to install the main cables. From afar, these cables might look thin, but in reality, each is nearly 1 meter thick, wide enough for a person to walk on. But then came another challenge. How could these enormous cables cross a canyon more than 1,400 meters wide? The answer: drones. A drone first carried a thin pilot rope across the canyon, connecting both sides. That rope was then used to pull a thicker rope, and that one pulled an even thicker one, repeating the process several times until a temporary aerial walkway, known as a catwalk, was built between the 2 towers. Along this catwalk, engineers began installing the cable strands. Each strand composed of 91 high-strength steel wires, each just 5.7 millimeters in diameter. The first strand was the most critical. It served as the reference line for all subsequent strands. Using total stations on the ground and Beidou satellite positioning, engineers kept the installation error within 2 millimeters, ensuring that every following cable would be perfectly aligned and tensioned to precision. And when all 217 cable strands have been pulled into position, they are compressed and fastened together using a cable compactor, finally forming a single main cable. Once both main cables were fully tensioned, the project moved to the next critical stage, lifting the main girder. The main girder of the Huajang Canyon Bridge weighs the equivalent of 95 Y-20 transport aircraft and was divided into 93 segments, which were assembled simultaneously from the center toward both sides. Each segment weighs 200 tons, roughly the same as lifting an entire blade set of the world's largest wind turbine. What made it even more difficult was that all this lifting had to be done under the constant threat of strong canyon winds. Thanks to a smart cable crane system capable of millimeter-level precision control, the main girder was finally joined seamlessly, marking the completion of the world's highest bridge's main structure. Construction of the Huajang Canyon Bridge began on January 18, 2022. By April 2023, the first bridge tower had risen to 653 feet. In January 2024, the main suspension cables were fully installed. By January 2025, the main girder was joined, and in August 2025, the bridge underwent a full-scale load test. Finally, in September 2025, it is scheduled to officially open to traffic. In just over 3 years, engineers completed this record-breaking megastructure in terrain once deemed almost impossible for modern construction. During the load test, 96 heavy trucks, with a combined weight of 3,700 tons, were placed across the bridge, while more than 400 sensors continuously monitored stress, deformation, and vibration in real time. The results confirmed that the bridge meets the highest international safety standards, and through a digital twin system, a long-term health monitoring model was established to track the bridge's condition in real time. The Huajang Canyon Bridge is not just a bridge. It is a smart megastructure integrating intelligent sensing, digital twin technology, and wind control systems. Equipped with over 400 high-precision sensors, it continuously measures temperature, wind speed, stress, and vibration, with all data transmitted to a central digital twin platform. This enables engineers to predict potential fatigue points, optimize maintenance cycles, extend the bridge's lifespan, and reduce maintenance costs. In terms of wind and vibration control, the bridge adopts a new aerodynamic deck profile and high-performance steel box girders to minimize the risk of vortex shedding and resonance. Additionally, LiDAR sensors continuously monitor wind speed and direction, while temperature-controlled smart chips and cooling water systems embedded within the bridge towers help prevent structural stress concentration under extreme weather conditions. The significance of the Huajang Canyon Bridge goes far beyond its technological marvel. It shortens the cross-canyon travel time from 70 minutes to just 90 seconds, allowing once isolated mountain towns to finally join China's national expressway network for the first time. The bridge sits along the Lian Expressway, a 94-mile corridor connecting western Guizhou with the Pearl River Delta, one of China's most economically dynamic regions. Its opening will not only boost logistics efficiency, reduce fuel consumption and vehicle wear, saving millions of dollars in economic losses every year, but also stimulate tourism, hospitality, and eco-industries across a 19-square-mile area. The bridge deck itself incorporates a glass skywalk, bungee platforms, earning it the title of China's new landmark on par with the Golden Gate Bridge. The service area is named Yundu, meaning crossing the clouds via one bridge. There, visitors will stand 1,000 meters above sea level, gazing across the sea of clouds, and witness firsthand the awe-inspiring power of this engineering masterpiece. The Huajang Canyon Bridge is not only a pride of Guizhou province, but also a symbol of China's leap in bridge engineering technology. On the global highest bridges ranking, China occupies 8 of the top 10 spots, with half of them located in Guizhou alone. The completion of the Huajang Canyon Bridge has once again inscribed the world's highest bridge under China's name. Compared with the Milo Viaduct in France, the Huajang Canyon Bridge wins on deck height. Compared with Japan's Akashi Kaikyo Bridge, it faces more complex, mountainous terrain and wind conditions. Compared with the Golden Gate Bridge in the US, it surpasses it in span, wind resistance, and structural precision. It not only transcends the old definitions of world's highest and world's longest, but also establishes a new paradigm for suspension bridge design under extreme terrain conditions, providing a technical precedent for future projects spanning the Himalayas, the Andes, and other deep canyon regions. Across Guizhou province, there are now over 30,000 bridges spanning valleys and rivers. These bridges not only weave together the high-speed transportation network, but also connect the lifeblood of the economy, cultural ties, and hopes for daily life. Guizhou was once called a place where no patch of land is level, but today, with the opening of the Huajang Grand Canyon Bridge, this misconception is being completely rewritten. Through the connection of bridges, mountains are no longer barriers, and even the clouds can be traversed. Millions of peaks now finally have millions of paths forward. The Huajang Grand Canyon Bridge not only links the roads on both sides of the canyon, it also connects Guizhou to its future. In the future history of bridge engineering, people will remember this name, Huajang Grand Canyon Bridge, a miracle descending from the clouds. With a deck height of 625 meters, it sets a new world record. Built in just 3 years, it demonstrates the power of China's infrastructure. And with digital intelligent management, it opens a new era in bridge engineering. It is more than just a bridge. It is a signal that China is leading the next era of human infrastructure. As the sun sets over Guizhou's mountains, its towers gleam like beacons of a nation's progress, a symbol of China's relentless pursuit of innovation, and a reminder that no peak is too high, no valley too deep, when human determination meets engineering genius. The world's highest bridge, the Huajang Grand Canyon Bridge, stands as proof that the future of infrastructure has already arrived. Indeed, transportation is the cornerstone of economic development and a crucial guarantee. Prosperity can only come when people and goods can move smoothly. Engineering and technology are forces that reshape the world, accelerating the wheels of history and fueling the progress of human civilization. Today, as China rises to become the world's second-largest economy and the leading manufacturing powerhouse, it is also proving its extraordinary engineering capability, gaining global recognition as an infrastructure giant. A series of breathtaking mega projects has showcased China's national strength and vitality to the world. Amid global economic shifts and China's new stage of development, these projects, defined by their massive scale, technical complexity, enormous investment, and long-term impact, span transportation, construction, water management, energy, and even defense. In just a decade, China has built and put into operation 45,000 kilometers of high-speed rail lines. By comparison, Japan and Europe took nearly 3 times as long to develop their own high-speed networks, and their scale is only a fraction of China's. Today, China's high-speed rail network alone exceeds the total of all other countries combined. Technologically, it has moved from importing to leading, pioneering the high-speed rail 4.0 era. The Three Gorges Dam is the largest and most complex hydropower project on Earth. The South to North Water Diversion Project is the most ambitious interbasin water transfer in human history, and the land reclamation in the Nansha Islands has been hailed as a miracle of nature's craftsmanship. And among these mega projects, one is pushing the very limits of human engineering, the world's largest island-to-land connection project. From the sky, you're about to witness one of the boldest engineering feats on Earth, the Huajang Bridge, the world's largest island-to-mainland connection. Its 1,650-meter main span leaps across the sea in a single breath, holding the crown as China's longest-span bridge for 10 years straight. But this is just the beginning. Together with the Jintang, Taoyaomen, Shangjiaomen, and Chang'an bridges, a chain of mega bridges stretches nearly 50 kilometers, binding once isolated islands into one seamless whole. 9 years later, the 8-kilometer Yushan Bridge rose to link Yushan Island with Daishan Island. 12 years after that, the 25-kilometer Zhoushan-Daishan Bridge connected Daishan Island to Zhoushan's main island. Together with the 32.5-kilometer Donghai Bridge, which links Shanghai to Shaoyangshan Island, and the Liuheng Highway Bridge now under construction, a series of expressways have stretched across the sea, building new land right above the waves. The result? China gained the world's busiest cargo port, the second largest offshore green petrochemical base, and its very first major fishing ground. This is not just a bridge. It's a super connection that reshaped China's coastline and redefined what's possible in modern engineering. After conquering cross-sea bridges, China has set its sights on an even greater challenge: undersea tunnels. Here, you are about to see the world's longest undersea high-speed rail tunnel, the Jintang Undersea Tunnel. Stretching 16.18 kilometers in total, with 11.21 kilometers of shield-driven section beneath the seabed, this tunnel is nothing short of a super engineering feat. Its cross-section measures a massive 14.5 meters in diameter, as tall as a 5-story building, large enough to accommodate dual high-speed rail tracks. The construction relies on the colossal shield machine, Ding'ai, with a cutter head nearly 15 meters across. Its steel blades work like the fangs of a giant beast, slicing through layers of rock and soil. Guided with pinpoint accuracy by China's Beidou satellite navigation system, it advances toward another shield machine, Yongzhou, coming from the opposite direction. Deep under the seabed, the two machines will finally meet with millimeter-level precision. So why is the Jintang Undersea Tunnel hailed as the world's #1? The key lies in one word: high speed. Its design speed reaches 250 kilometers per hour, far exceeding the Channel Tunnel between Britain and France and Japan's Seikan Tunnel. By high-speed rail standards, Jintang's length and scale are unmatched anywhere on Earth. But the greatest challenges are not just about being long. The tunnel runs 78 meters below sea level, where shield machines must withstand enormous water pressure. Along the route, they face 28 geological transitions, alternating between solid rock and soft soil. To overcome this, engineers made special modifications, adding water injection pipes on the cutter head to handle sticky clay, reinforcing the sealing systems to resist extreme pressure, and upgrading the drive system for long-distance stability. Construction follows a dual shield approach. Yongzhou advanced 4,940 meters from the Ningbo side. Ding'ai dug 6,270 meters from the Zhoushan side. Why the difference? Because the geology is uneven. Rock on one side, softer soil on the other, making symmetrical digging impossible. The final meeting point was deliberately chosen within a stable rock formation, the only way to guarantee a safe and accurate junction. And accuracy is everything. In an undersea tunnel, even the tiniest error in manual surveying multiplies over distance. One wrong calculation, and you could end up with two separate tunnels instead of one. To prevent disaster, engineers deployed 6 Beidou satellites linked to the shield machine's auto-navigation systems, correcting deviations in real time. In the end, the alignment error was kept within just 2 centimeters. Then came the final challenge: how to remove the machines. When the two titans meet underground, there is no exit ahead and no way back. The solution? A technique called shedding the shell. The shield machines are dismantled piece by piece and hauled out, while their massive steel casings remain in the tunnel, permanently reinforcing its structure. According to plan, the Jintang Undersea Tunnel will be fully bored through by the end of 2026 and open to traffic with the Yangzhou Railway in 2028. Once complete, passengers will be able to travel from Ningbo to Zhoushan in just 30 minutes by high-speed train, ending the island's long history of having no rail connection. And while officials may not say it openly, many already see the bigger picture. This tunnel is not just a passage to Zhoushan, it may well be the test bed for the Taiwan Strait Tunnel. If China ever attempts to build across the strait, this will have been the most critical rehearsal. So, just how advanced is China's technology for building underwater tunnels? To answer that, let's take the Hong Kong-Zhuhai-Macau Bridge Tunnel as an example. Here's the big question. The ocean is full of water. So how do you build a tunnel beneath the seabed? And how did Chinese engineers manage to construct a 6.7-kilometer underwater tunnel 40 meters below sea level? At first, engineers considered using tunnel boring machines. But since TBMS require extremely high stability, the tunnels they dug went much deeper than the design required. That meant they needed another solution. Their goal was to build a massive sea-crossing bridge that could connect Hong Kong, Zhuhai, and Macau, a project now hailed as one of the 7 wonders of the modern world. The final solution was immersed tube tunnel technology. In this method, trenches are dredged on the seabed. Prefabricated concrete tunnel sections, called immersion tubes, are then lowered into these trenches, aligned underwater, joined together, and finally backfilled with sand and gravel. Each tunnel section is 180 meters long, weighing 76,000 tons, about the same as an aircraft carrier. Each one contains 2 3-lane carriageways and 2 service tunnels. Chinese engineers had to lower and align these massive tubes one by one, but manufacturing a single 180-meter, 76,000-ton reinforced concrete unit in one piece was practically impossible. The solution? Engineers divided each tunnel section into 8 smaller parts, prefabricated them in a factory, and then joined them into a single 180-meter unit. In total, the project consumed 330,000 tons of steel and 2 million tons of concrete, enough to build 8 Burj Khalifa towers. On the uninhabited Niutu Island, over 3,000 workers built a massive factory in just 100 days. Its only task to produce the 33 immersion tubes required at a rate of 2 per month, each weighing 76,000 tons. After more than 1,400 days of construction, nearly all tunnel sections were in place. The final piece, E30, was carefully lowered into position. Slowly, steel cables lowered the giant section to the seabed, while engineers above monitored every detail in real time. After 26 hours of precise adjustment, E30 was finally seated in place. Divers then entered the seabed, carrying out millimeter-level measurements to ensure the alignment was perfect. Once confirmed, the last segment was sealed, and the world-shocking Hong Kong-Zhuhai-Macau Bridge underwater tunnel was complete. This is not just about a tunnel. It's about speed, precision, and national ambition. A netizen compared China's rise to human learning. You get smarter from both success and failure. China is like a sponge, absorbing and improving technology. Many of these mega projects are not done for show, but to make things better. As one user put it bluntly, the US spends over $1.5 trillion on defense instead of modern infrastructure. Imagine what both countries could achieve if they worked together on infrastructure. One foreign commenter said, "These mega projects showcase China's engineering prowess and ambition, reshaping the country's landscape and connecting its vast population." But these projects come at a hefty price, often hidden from public view. The construction of these mega projects often involves massive land acquisition, deforestation, and the displacement of local communities. The environmental impact of these projects is significant, contributing to air and water pollution, habitat destruction, and climate change. Recent examples include the Three Gorges Dam, which displaced millions and altered the natural flow of the Yangtze River, and the Belt and Road Initiative, which has raised concerns about environmental sustainability in participating countries. While these projects promise economic growth, they often come at the expense of social equity and human rights. The construction of these projects has led to forced evictions, the suppression of dissent, and the exploitation of laborers. The lack of transparency and accountability surrounding these projects raises concerns about their social and ethical implications. Others see it in even grander terms. China is the first since ancient times, just sleepy for a while. Now it's returning to its rightful place. No one can stop it. Construction flows in the bloodstream of Chinese people. They have been building for thousands of years, and they're still building. The sky is the limit for China's achievements. From cross-sea bridges to underwater tunnels, from high-speed rail networks to megawater projects, China keeps redefining the limits of human engineering. These are not just structures of steel and concrete, they are symbols of ambition, vision, and determination. Of course, such projects spark debate worldwide. Some marvel at China's speed and precision, while others question the social and environmental costs. But one thing is undeniable. China has shown the world that the future is not something you wait for, it's something you build. Around the world, a wave of massive construction projects is reshaping the future. From California's $130 billion high-speed rail to Saudi Arabia's ambitious Line City, we've been watching these developments for years. But beyond the headlines, other breathtaking mega projects are quietly transforming our planet. Take China's Xiong'an Smart City, for example, a $95 billion investment built from the ground up in just 7 years. Over 3,000 buildings have risen, and the city features digital roads that collect real-time traffic data and calculate optimal emergency routes. These are not just construction projects, they are building the future. China is known for its ancient history and booming economy, but perhaps the most astonishing thing is its incredible speed of construction. While the U.S. high-speed rail faces decades of delay and Saudi's Line City remains largely on paper, China has turned barren land into a futuristic city at breakneck pace. This $95 billion mega project didn't just build skyscrapers, it laid down roads that can think. These smart roads calculate the fastest routes for emergency vehicles automatically. And this is only the beginning. China's ongoing mega projects are redefining the scale of modern infrastructure. So here's the big question. How is China building so fast? And how will these projects shape the global future? Today, we explore China's most mind-blowing mega projects that are not only changing cities, but global standards. China has already done what many thought impossible. It's building a $95 billion smart city on the flat plains of Hebei and doing it at breathtaking speed. This is Xiong'an New Area, a second capital hub designed to relieve Beijing of its non-core functions. Spanning over 2,000 square kilometers, the city is planned as a high-tech, green, intelligent, and livable urban space. Unlike traditional cities, Xiong'an was designed from scratch, both above and below ground. Underground, there's a complete transportation and utility system. Above ground, the city emphasizes nature and open green spaces. The infrastructure blends subways, high-speed rail, water systems, power grids, and 5G networks, all into one ecosystem. It's thinking roads, powered by 5G and IoT sensors, monitor traffic in real time, adjust signals dynamically, and can even calculate optimal emergency routes. Imagine a fire truck getting all green lights to reach the scene in record time. That's not science fiction. That's happening now. While other countries debate whether to build, China is already focused on how to build better. This difference may define the race for the future. So why can China build these colossal projects in just decades? While many Western countries spend years debating a single subway line, the answer may lie in policy execution, integrated supply chains, and a bold long-term vision for infrastructure. China doesn't wait until every problem is solved before starting. It starts and solves problems along the way. In China, infrastructure isn't just an economic tool, it's a national strategy. Each rail line, tunnel, and bridge represents a vision for the future. Of course, these projects come with their own challenges, from environmental concerns to resettlement and social equity. But one thing is clear, China is redefining what's possible through action. In the future, global competition may not be just about technology, but about who builds faster, smarter, and with greater resolve. For decades, China's infrastructure development has been nothing short of astonishing. Bridges rise like bamboo shoots after rain, leaping across canyons, spanning vast rivers, and linking regions once divided by nature. They've transformed not only how people travel, but the very geography of the nation. From Chinese roads to Chinese bridges, from colossal tunnels to massive dams, from high-speed rail cities to vast underground networks, China's engineers continue to break world records, one project after another. These national icons power the nation's economy with unstoppable force. The world is still the same world, but China is no longer the China of the past, where there are mountains, roads are carved, where there are rivers, bridges rise. With courage and mission, Chinese engineers turn the impossible into reality, again and again. At this point, many American viewers might be wondering, is China already a developed country? Then why does the US government still refuse to officially recognize it as such? Why do Western media outlets constantly amplify the China threat narrative? And why do global research reports often rank China as the world's #1 in so many fields? The answer is simple, because China has become powerful, and it did so with astonishing speed. A country once written off as an agricultural backwater is now emerging as a global industrial powerhouse. And that transformation happened in just a few decades. To the world, that's not just growth, it's a shockwave. Seeing China grow stronger and stronger, the United States is starting to panic.
I am stunned to hear some of the rhetoric coming from the other side around a bill that finally, after decades, recognizes that we are in a very stiff competition with China. And for the longest time, America didn't know it. China was in this competition. China was doing everything they could to dump steel in our country. They spend 7 to 9% of their GDP on infrastructure every year. They got islands in the South China Sea. They told us they weren't going to militarize them. Now they have. They have bases in Africa, long-term raw material contracts in African countries to solidify their control of precious metals so that our phones, our weapon systems, our computers, they have a plan. This is not complicated, but it's being seen through the prism of our current broken, insane political system. And so what we're trying to do here is recognize that they're winning. China has a 10-year plan, 50-year plan, 100-year plan. We live in a 24-hour news cycle talking about Dr. Seuss, Big Bird, M&M's, SpongeBob, and we're getting our clock cleaned.
China's strength didn't happen by luck. China's rise is one of the most dramatic national transformations since World War II. It carved roads through mountains and built bridges across rivers. And in that relentless pursuit of progress, China earned a nickname that shook the world, the infrastructure maniac, demolishing a bridge in just 25 hours, upgrading a major train station overnight. The speed of Chinese infrastructure builds is unmatched and nearly unbelievable. But there's more to it than just speed. China's engineering marvel even made headlines in the UK, where a popular TV show sparked heated debates about the project, while using it to roast their own country's notoriously inefficient railway system.
How the Chinese do these things, and I noticed that they were able to build a whole new station in the space of 9 hours by flooding it with thousands of workers. We should be much more imaginative about getting infrastructure in quickly instead of condemning people to being isolated in remote areas.
Mel and I shared a taxi coming here, and the commentary I can tell you in the taxi was that the roads looked better than the area where we were living in England. I'm delighted to hear it, but I have to say to you, it was much better than in Buckinghamshire. But everybody in their own area complains, and the truth is our road repairs have been very, very bad, and it's deteriorating. And yes, austerity has prevented expenditure on all sorts of things that we could need to spend money on. But equally, if we cannot borrow...
China now has over 143,000 kilometers of expressways and 30,000 kilometers of high-speed rail, both world records. From remote villages to booming cities, the entire country is connected by a vast and seamless transportation web. To build that, China had to overcome extreme terrain, geological complexity, and ecological challenges. And it did, again and again. Take the Hong Kong-Zhuhai-Macau Bridge, for instance. At 55 kilometers, it's the longest sea-crossing bridge on the planet. Engineers call it the Mount Everest of bridge building. And yet, China built it. under tight constraints with unmatched precision. This isn't just speed, it's engineering power. Behind the nickname infrastructure maniac lies more than just engineering power. It reflects decades of scientific innovation, bold planning, and the will to execute at scale. Each bridge, tunnel, and highway is not just concrete, it's progress. And that progress is meant to serve the people. Infrastructure isn't just about concrete and steel. It carries the hopes of a people, the dreams of a better life. On this ever-advancing journey, China's infrastructure fanatics will keep pushing forward, driving the great vessel of China steadily through the waves of the future. Welcome to a deep exploration of China's Pinglu Canal project, an undertaking so massive that it is altering the very structure of the nation. China's geography has played a crucial role in shaping its civilization and agricultural development. This vast country is home to diverse terrains, from the fertile plains along the Yangtze River to the arid expanses of the north. These geographical contrasts have not only influenced agricultural practices, but also shaped the historical development of communities across the nation. Let's begin with this map of China. Excluding Taiwan and the islands of the South China Sea, it marks 55 coastal cities in China. Among them, the vast majority have played vital roles in the country's economy, trade, transportation, and culture. Yet in the southwest corner of the map, the three coastal cities of Guangxi, Qinzhou, Beihai, and Fangchenggang have long remained a hidden corner under the halo of China's coast. Despite being born with natural deep-water harbors and holding the golden key of being China's only province-level region, directly connected to ASEAN by both land and sea, Guangxi has never received the status and attention it deserves. Even today, though the Beibu Gulf port has entered the top 10 Chinese ports by cargo throughput, when people mention Guangxi's coast, it is still seen merely as a destination of beautiful beaches and affordable vacations, rather than a hub of maritime ambition, prosperity, and strength. Guangxi's sea is modest, and its rivers seem even more reserved. Flowing through it is the Xizang River, Guangxi's most important water system and one of China's busiest inland waterways. Each year, over 200 million tons of cargo pass through the Xizang, but most of it eventually flows into the Pearl River Delta. Blocked by the 10,000 Great Mountains, this golden waterway nourishes a world-class bay area, yet it has little chance to directly benefit its own hinterland. Despite being coastal, Guangxi lacks a direct river-to-sea corridor. The world is clearly close, yet Guangxi has been forced to take the long way around. This is not only Guangxi's helplessness, but also a regret for the entire waterway system of southwest China. It is time to cut through the mountains with a canal to connect rivers to the sea. The Pinglu Canal is the first canal built since the founding of New China, and a century-defining project after the Grand Canal. The Pinglu Canal is a vital part of the new Western Land-Sea Corridor. It serves as a 100 million ton level water transport artery linking the Pearl River Zhejiang River Basin with the Beibu Gulf Port. Upstream, it connects with the Zhejiang shipping mainline, known as the Golden Waterway. To the west, it extends via the Yongjiang River directly to Nanning and the Zuo and Yu rivers, reaching into Yunnan. To the east, it flows through the Yujiang River straight to the Guangdong, Hong Kong, Macau Greater Bay Area. To the north, it connects through the Qianjiang, Hongshui, or Liujiang rivers to Guizhou. To the south, it flows out into the Beibu Gulf. The Pinglu Canal has a total length of about 140 kilometers. It starts from the Pingtang River estuary of the Shijin Reservoir in Hangzhou, about 150 kilometers downstream of the Yongjiang River in Nanning. From there, it crosses the watershed between the Reshaping River and the Jiuzhou tributary of the Qinjiang River, runs through Luwu Town in Lingshan County, Qinzhou City, follows the mainstream of the Qinjiang River southward, and finally enters the waters of Qinzhou Port in the Beibu Gulf. Construction officially began in August 2022, with a planned duration of 52 months. The main structure is scheduled to be completed by the end of 2026. This new canal will become China's first major artificial canal in more than 1,400 years, since the famous Grand Canal itself. It will link the inland river system directly to the sea. This time, Guangxi's rivers will flow southward directly into the sea, rather than detouring through the more economically developed neighboring province of Guangdong. In fact, China has been considering digging such a new canal for decades. As you can see, the distance from Nanning to the Beibu Gulf is very short, just over 100 kilometers. The new canal will shorten the travel distance by 560 kilometers, which translates into about 10 days saved in transportation time. However, the Pinglu Canal comes at a hefty cost, with investment exceeding 10 billion US dollars. Is it truly worth it? The answer is certainly yes. Water transport is cheaper than road or rail. In addition, China has adopted a very conservative approach to forecasting returns, assuming that the investment will break even in 30 years. Yet the canal itself can last at least a century with minimal maintenance costs. To fully understand the economic benefits, one must also consider the additional 800 kilometers saved if cargo from Guangxi is destined for ASEAN countries. The canal will directly connect inland rivers to maritime trade with ASEAN nations, offering massive potential. Moreover, China already has methods in place to accelerate upstream and downstream cargo transport. The Pinglu Canal is designed with 3 locks, capable of accommodating ships of up to 5,000 tons. These locks will feature smart traffic guidance through data sharing. In China, only some sections of the Yangtze River can handle such large vessels, so the designers of the Pinglu Canal have clearly anticipated and planned for heavy shipping traffic in the future. Over the past decade, trade between Guangxi and ASEAN has accounted for nearly half of Guangxi's total trade, with its value almost tripling and its annual growth rate far exceeding the national average. All infrastructure construction is closely tied to market expectations. The Pinglu Canal will promote supply chain connections across industries such as automobiles and petrochemicals. Not only Guangxi, but also provinces in central and western China will benefit from it. As China accelerates the construction of river transport infrastructure, projects like the Pinglu Canal will usher in the next stage of economic growth and social empowerment. At first glance, it might seem like just a massive construction site, bulldozers, cranes, endless concrete. But in reality, what you are witnessing is China building its first major canal in over a millennium. And it's not just anywhere. It cuts through the most rugged terrain of southern China. You may have already marveled at China's construction speed, bridges spanning entire gorges, railways piercing mountains. But this time, they are doing something different. This is the Pinglu Canal, one of the most ambitious infrastructure projects in China in recent years. The Pinglu Canal stretches 134.2 kilometers, starting at the Pingtang River estuary of the Shijin Reservoir in Hangzhou and ending at the Xinjiang River flowing into the Beibu Gulf. This final connection to the sea is the key to the canal's significance. It transforms Guangxi's inland hinterland into a potential export hub. China has a long history of constructing artificial canals. The most famous is the Grand Canal, which stretches over 1,700 kilometers and has supported the nation's economic operations for centuries. From a bird's-eye view, we can easily spot the unique characteristics of the Grand Canal. On the plains of eastern China, it is the only north-south channel among all the east-flowing rivers. It not only links up the 5 major river systems, namely Hat River, Yellow River, Huai River, Yangtze River, and Shantung River, but also connects dozens of cities along the way, including Beijing, Tianjin, Jining, Yangzhou, and Hangzhou, all by itself. And it has been flowing for the last 2,500 years or so. It transported grain from the fertile southern regions to the political centers in the north and unified the national transport system during the Sui and Tang dynasties. However, after that golden age of water transport, China gradually shifted its focus to highways, railways, and aviation, especially after the 20th century. Water transport took a back seat. For over 1,000 years, China did not build any new large-scale artificial canals. So why revive this idea now? The reason is that China's economic landscape has changed. While the eastern coastal provinces remain manufacturing powerhouses, the central and western provinces, such as Guizhou, Yunnan, and Sichuan, are rapidly developing. These regions are far from the sea, and transporting factory goods to ports like Shanghai or Shenzhen takes both time and money. The canal offers a more efficient alternative, cheaper than rail, more energy-saving than trucks, and capable of transporting large volumes of cargo. This is the significance of the Pinglu Canal, not just reviving an ancient tradition, but solving modern logistics challenges. Just as the Grand Canal once transformed internal trade in ancient China, this canal will connect China's new regions to global markets. But this project is more than just pouring concrete. It involves logistics, strategy, economics, and possibly even political considerations. Theoretically, digging a 134-kilometer canal through hills and rivers might seem excessive, especially in a country with some of the world's busiest highways and advanced high-speed rail. But this is not about showing off. It's about solving a very real logistics problem. Many areas in western and southwestern China, such as Chongqing, Guizhou, and Sichuan, are industrially dense, with factories, coal mines, steel plants, and cement factories. But they share a common problem. They are landlocked, far from the sea. Transporting goods from these regions to eastern coastal ports like Shanghai or Shenzhen usually requires over 700 to 1,000 kilometers of travel, which is slow, costly, and heavily reliant on already overburdened railways and highways. The Pinglu Canal changes all of this. It provides these inland provinces with a direct waterway to the Beibu Gulf, which is crucial for companies shipping bulk goods. Even small transportation savings could determine profits or losses. This is not only a logistical improvement, but also part of a larger strategic plan. The canal plays a key role in China's new international land-sea trade corridor, linking railways, highways, and waterways, especially connecting underdeveloped Western regions directly to Southeast Asia and global markets. Construction officially began in August 2023, with a total budget of approximately $10 billion, and completion is expected in 2026. Once operational, ships will be able to transport goods between inland factories and international ports without using any highways or railways. The canal is designed to accommodate vessels up to 5,000 tons, primarily for bulk cargo. At full capacity, it is expected to transport over 95 million tons of cargo annually, roughly twice the early shipping volume of the Panama Canal. However, building a giant canal from scratch is no easy task, especially in uneven terrain. The Pinglu Canal must traverse mountains, hills, rivers, and villages, requiring road diversions, resident relocations, and terrain reshaping. The scale of work is enormous, with extremely precise requirements. Elevation differences exist along various parts of the canal, which is why 3 large locks, essentially water staircases, have been designed. The largest, the Tantang Lock, will be the largest water-saving lock ever built, allowing large vessels to navigate steep slopes while minimizing water consumption. This is particularly crucial in regions where seasonal droughts may cause water shortages. Along the canal, there are more than 90 bridges and over 40 kilometers of excavation zones, including several deep rock cuts. In some areas, up to 13 million cubic meters of earth must be removed, equivalent to more than 5,000 Olympic-sized swimming pools. Unlike older canals, this canal is built to modern standards, reinforced embankments, automated water control systems, and integration with intelligent logistics platforms. Thousands of workers and dozens of heavy machines, excavators, dredgers, and concrete pumps operate around the clock. Coordinating construction along such a long and narrow corridor is itself an engineering challenge. Once completed, the canal will function more like a highway than a traditional waterway, efficiently handling high-volume traffic with low maintenance costs. When people think of canals that transform cargo flows, they usually think of the Panama Canal and the Suez Canal, which connect oceans. The Pinglu Canal, however, is an inland canal linking rivers to a gulf, so it does not compete with Panama or Suez in global shipping. But that is not the point. Panama and Suez are shortcuts for international shipping, while the Pinglu Canal focuses on domestic efficiency. Despite its lesser fame, it is strategically just as important for China. At full capacity, the Pinglu Canal can handle over 95 million tons of cargo annually. This is not just an impressive number, it represents a major shift in how goods flow in southern China. Previously, cargo from inland factories to coastal ports had to travel 700 to 1,000 kilometers by truck or train, time-consuming and costly. This is especially significant for heavy materials like coal, cement, grain, or steel. The canal allows goods to float directly to the coast, cheaper, faster, and with lower emissions. Some routes are expected to shorten travel distances by up to 560 kilometers, saving about a day of transport time. This is a major benefit for China's inland provinces. Cities like Luzhou and Nanning, previously far from main shipping routes, now have the opportunity to become regional trade hubs. Industrial parks, logistics centers, and export zones are already being planned along the canal. The ports of the Beibu Gulf, especially Qinzhou, Fengchenggang, and Beihai, were previously considered second-tier ports, but with the continuous influx of inland cargo via the canal, they are becoming key players in China's overall trade strategy. Nationwide, the canal gives China greater control over internal logistics. No longer entirely dependent on a few eastern megacities, the country now has new routes to transport goods to Southeast Asia and beyond. In a time when global supply chains are under constant pressure, this flexibility is extremely important. The Pinglu Canal also strengthens China's trade links with Vietnam, Thailand, and Malaysia, creating a southern trade route that bypasses Taiwan or some sensitive South China Sea passages. In short, it is not just infrastructure, it is a strategic lever. Of course, large-scale construction projects always involve trade-offs. Excavating 134 kilometers of land inevitably affects local residents and the environment. Thousands of residents along the route have been relocated and many villages cleared. The government has provided compensation plans, but not everyone is satisfied. For older residents, losing ancestral land or being forced to leave long-established communities is not just about money, it concerns identity, history, and emotional attachment to the land. Environmentally, the canal passes through wetlands, farmland, forests, and biodiversity areas, placing pressure on local ecosystems, including fish, migratory birds, and groundwater resources. To mitigate this, the government and engineering teams have implemented multiple protective measures: ecological corridors, water-saving locks, real-time monitoring systems, sediment interception, and drainage facilities to prevent erosion and sediment damage to the rivers. Experts point out that these measures require long-term supervision and maintenance, especially during extreme weather, such as floods or droughts. The canal draws water from the Huajang Reservoir in Hangzhou, which could affect agriculture and residential water use during dry seasons. Engineers state that this has been accounted for with reservoirs and water diversion systems, but uncertainties remain under climate change. Additionally, although water transport is generally more environmentally friendly than road transport, increased shipping brings risks of higher emissions, noise, fuel spills, or cargo leakage, particularly in previously quiet rural areas. Once fully operational, the canal will not only transport goods but could fundamentally transform how southern and western China participate in global trade. Local governments anticipate the canal transporting millions of tons of cargo annually, and as industrial zones, export hubs, and manufacturing parks develop along the route, this number could increase even further. However, such ambitious plans also carry risks. One major concern is underutilization. If companies do not adjust their logistics to fully leverage the canal, it could, like other large projects, remain partially unused after completion. Long-term maintenance is also a challenge. Locks, bridges, and automated systems require ongoing upkeep, especially during dry seasons when water levels and sediment accumulation need monitoring. Environmental management is another test. Despite official promises of real-time monitoring, responding to climate change and water resource pressures will require continuous investment and transparency. There is also a balancing issue. Can the canal provide economic opportunities without causing permanent damage to the environment and vulnerable communities? This is a matter that local governments must carefully manage over the long term. Undeniably, China is doing something that no other country in the world has attempted, building a high-tech inland canal system at record speed while addressing economic and strategic concerns. The Pinglu Canal may not make headlines like the Suez or Panama Canals, but it is equally important for China. This is a $10 billion infrastructure bet designed to activate inland trade, reduce transportation costs, and give the country more control over its supply chains. Construction is progressing rapidly, and China is betting on its success. If this project succeeds, the canal could become a benchmark for other countries around the world to reconnect their inland regions and reduce reliance on trucks and railways. High up in the sky, the elaborate network of atmospheric circulation delivers water vapor from the four oceans continuously into China. Like rivers in the sky, they descend to Earth and become the 45,000 rivers that run and rush across the nation, bestowing China with one of the most dense river systems and the most diverse landscapes in the world. Let us begin with the Yangtze River, China's longest and also the largest by volume and watershed area. Its annual runoff accounts for 36% of China's grand total, equivalent to that of 17 yellow rivers combined. During flood seasons, the maximum runoff can triple its normal. If this imposing volume of water is not handled properly, a catastrophe awaits. If only there were an enormous pond that could store all the floodwater. There it is. What you see now is the largest reservoir ever built in China, the Three Gorges Reservoir. The Three Gorges project is one of the world's largest water control systems, about 2,335 meters long and 181 meters high. It integrates flood control, power generation, and navigation. It can store enormous flood volumes, supplies world-scale hydropower capacity, and lowers the difficulty and cost of shipping on the Yangtze. The project has sparked debate over resettlement and environmental impacts, but its strategic role in flood mitigation and energy security is substantial. With a storage capacity of up to 45 billion cubic meters, it can swallow more than 3,000 West Lakes. But this is still not sufficient. When you look at the entire Yangtze River, you will see in the upper mainstream the 4 cascade reservoirs known as Xiangjiaba, Siluodu, Baihetan, and Wudongde, and Tingziku, Gupitan, Ertan, and Jinping in the tributaries. Over 50 large reservoirs now guard the Yangtze watershed. In terms of water storage capacity, we have virtually built 3 more Three Gorges Reservoir. Every year before the flood season arrives, reservoirs empty part of their storage in preparation. The emptied volume is called the flood control capacity of a reservoir. When floods arrive, it is used to retain excessive water behind the dams. This prevents flood peaks from hitting the downstream simultaneously and compounding the risk. Meanwhile, the retained floodwater is released downstream in a managed way so that flood peaks are either reduced or delayed. This ensures safety in the downstream. The entire watershed is also under the surveillance of more than 30,000 monitoring stations and meteorological satellites that relay precipitation and water level data in real time. They provide scientists with precise rainfall and flood data, which enable unified scheduling of the reservoir cluster. The South to North Water Diversion Project is China's largest water transfer undertaking, divided into eastern, central, and western routes. The central route starts at the Danjiangkou Reservoir and runs about 1,432 kilometers through Henan and Hebei to Beijing. Rather than simply pumping water uphill, the project uses gravity-assisted channels, aqueducts, and tunnels to move southern water north. Completed over many years and involving the relocation of hundreds of thousands, the central route has delivered hundreds of billions of cubic meters of water by 2023, serving well over 100 million people and securing water supply for northern China. That equipped the entire route, this grand project is able to navigate through 8 provinces and 4 major river basins, diverting water over 2,000 kilometers cumulatively in an orderly manner. 9 years into its full operation, water sufficient to fill up the entire Yellow River has been diverted to North China, meaning that 170 million people in 44 cities now use water from the Yangtze River. Today, empowered by modern technologies, China is reshaping rivers like never before, and even create new rivers on this very ancient land. This is the Taihang Mountains. Hanging along the cliffs are not just roads, but also a river. It is the Huanghe Canal that diverts water to Linzhou in Henan province. Chronic droughts pushed the Linzhou people to hammer and carve this 70-kilometer-long waterway up high with bare hands and very basic tools. But 70 kilometers, it is barely a dot on the vast expanse of China. The temporary reservoir you see now are all man-made. China has more abundant water resources during summertime, and the vast of them belong to the southern regions. These artificial rivers are designed to break this extremely uneven distribution and restructure water allocation in China. Yet, creating artificial rivers puts man at the trying test of nature. In Shanxi province, a 98-kilometer-long tunnel penetrates the Qinling Mountains and diverts water from the Hanjiang River to the densely populated Guangzhong Plain. In Gansu province, water from the Yellow River traverses the desert, nourishing a string of oasis cities and resisting the expanding desert. The Hong Kong-Zhuhai-Macau Bridge spans roughly 55 kilometers and links Hong Kong, Zhuhai, and Macau. It's a highly complex maritime project that combines bridges, artificial islands, and an immersed tunnel to protect shipping lanes and sensitive ecological zones. Gigantic immersed tunnels were precisely installed with millimeter-level alignment, and the project used hundreds of thousands of tons of steel. Once opened, travel times between the cities dropped from hours to mere minutes, greatly advancing regional integration. China's high-speed rail network leads the world in scale and density, with over 40,000 kilometers of lines linking major cities into a high-speed web. With 40,000 kilometers of operating lines, far exceeding the total high-speed rail mileage of all other countries combined, this network tightly links more than 100 cities, serving a population of over 1 billion. Every year, it connects trillions of dollars in economic activity. Trains such as the Fuxing operate at several hundred kilometers per hour with remarkable stability, punctuality, and comfort. From ice-covered plateaus to tropical islands, this vast network operates at high speed every single day. And thanks to China's efficient, rapid construction capabilities, it is constantly expanding. This is one of the most ambitious mega projects ever undertaken by the Chinese people. And it's not the end, but just the beginning. Even more importantly, the core technologies of high-speed rail have been fully developed and industrialized domestically. China's standards and equipment are now being exported abroad, playing a growing role in high-speed rail projects worldwide. The Sichuan-Tibet Railway crosses high plateaus and active fault zones, one of the planet's most challenging rail routes. It traverses snow peaks, deep gorges, and unstable geology, confronting high altitude, thin air, and extreme weather. Construction required precise tunnel boring, aerial bridge assembly, and plateau-specific techniques. Landmark structures like the Yarlung-Zangbo River Bridge were erected with helicopter lifts and millimeter-precision steel assembly. Beyond connectivity, the line carries strategic and vital civilian importance. Starting from Tiananmen Square and moving 46 kilometers south along Beijing's central axis, a brand new world-class landmark has risen, the Beijing Daxing International Airport. Together with Capital International Airport, it forms a dual-hub system, providing powerful support for the coordinated development of the Beijing-Tianjin-Hebei region. From a mega engineering project to China's new national gateway, Daxing Airport has always been in the global spotlight. In 2016, it was named the #1 of the 7 new wonders of the world by The Guardian. The terminal complex covers an astonishing 1.4 million square meters, equivalent to 3.2 Tiananmen squares. Today, it has become one of the largest aviation hubs on the planet. Beijing Daxing International Airport, shaped like a phoenix, features an enormous single terminal designed for efficiency and passenger convenience. Seen from the sky, this airport is already breathtaking. The entire terminal radiates outward in 5 concourses, resembling a phoenix spreading its wings. With a total floor area of 1.4 million square meters, equivalent to 63 bird's nest stadiums, it is one of the largest single-structure terminals in the world. Its main roof is made up of more than 8,000 irregular curved glass panels, a construction challenge that was nothing short of hell level in the world of architecture. But what's truly remarkable is its efficiency and design philosophy. From security to the farthest boarding gate takes only 8 minutes on foot. It is also the world's first integrated transportation hub, combining high-speed rail, metro, intercity rail, and express lines, all beneath one roof. Add to that a fully automated baggage system, intelligent navigation, paperless boarding, and facial recognition, and passengers here hardly feel the weight at all. One detail during construction left a lasting impression. The central hall ceiling houses a dome of light, illuminated entirely by natural sunlight during the day, both energy-saving and visually stunning. Installing this dome was an extreme engineering challenge. Workers stood on scaffolding dozens of meters high, piecing it together millimeter by millimeter. And yet the entire civil construction of the airport took only 4 years, a feat hailed globally as a miracle of Chinese speed. With its completion, Beijing entered the era of dual airports, boosting its annual passenger capacity to 100 million. More than just an airport, this is a super gateway connecting China to the world, and a powerful symbol of China's modernization. To bridge spatial gaps between energy resources and demand, China built UHV transmission lines that move large amounts of clean power over great distances. Projects such as the Changji-Guquan 1,100 kilovolt DC line span thousands of kilometers and transmit tens of billions of kilowatt hours annually. With tens of thousands of kilometers of UHV lines, China now networks wind, solar, and hydro generation into major eastern population centers. Beidou is China's independently developed global navigation satellite system. From its inception in 1994 to global coverage in 2020, Beidou now operates dozens of satellites worldwide. In many scenarios, it outperforms standard civilian GPS, with meter-level and in some cases centimeter-level accuracy. It also supports short message services, precision timing, and global search and rescue. Beidou has proven critical in rescue missions and industrial applications, is part of international GNSS interoperability frameworks, and is increasingly offering services globally. In the future, every frontier of technology, autonomous driving, the Internet of Things, smart cities, intelligent manufacturing, and civil-military integration, will rely on pinpoint positioning, flawless timing, and unshakable navigation. At the heart of it all will be Beidou. High above us, across the boundless expanse of space, it has woven a precise and intricate web of stars, linking Earth to the heavens with invisible threads of light. Beidou is more than a triumph of engineering. It is a gift from Eastern civilization to this era, a coordinate in time and space that will guide the world into the future. In the digital age, 5G base stations, data centers, and the national internet backbone are the new infrastructure. China rapidly deployed millions of 5G sites, rolled out East Compute, West Store, and scaled IPv6 adoption. This digital backbone supports autonomous vehicles, industrial IoT, smart cities, and digital payments, an invisible but critical network that powers modern life. When you think of a desert, what comes to your mind? Endless sand? Scorching heat? No signs of life? Well, where deserts are not dying. The Taklamakan Desert, China's largest desert. For decades, its sands crept outward. Homes, roads, farmland, all lost to the wind. That story is changing. After 40 years of effort, China has built a 3,046-kilometer greenbelt encircling the desert, the longest man-made desert shield on Earth. It doesn't just stop sand, it's helping lift people out of poverty. So how did they do it? First came the basics: roads, irrigation systems, power grids. In 2024 alone, billions were invested in Xinjiang's desert control. Then came three models. Model 1, engineering. Lattices of straw checkerboards are laid across the dunes. They break the wind, slow the sand. On the edges of the Taklamakan Desert in Bachu County, factories produce reed mats in weaving machines, a faster process and a more durable product, and a new income stream for locals who install them. Model 2, biology. Drought-resistant plants take root in the sand, and hidden beneath some, a desert herb called Cistantia deserticola, nicknamed the ginseng of the desert. To grow the herb, you must grow the sand-fixing plants first. Ecology and economy intertwine. To scale this up, the government offered incentives for companies and farmers to lease desert land, turn it into farmland, and grow sustainable industries. Model 3, solar power. This desert gets endless sun, which is perfect for solar farms. In Shea County, 540,000 solar panels generate clean power, enough for the needs of 430,000 people a year, while anchoring the ground against erosion. Some regions have gone further by turning the desert into a destination. Macon County saw 500,000 tourists last year, creating jobs and boosting the local economy. And this is just the beginning. By 2030, Xinjiang plans to restore even more arid land and build a full industry loop, linking solar power, eco-agriculture, and desert tourism. The projected annual value? Over $1.4 billion. Over the past 4 decades, generations of desert fighters in China have discovered a powerful truth, that within the shifting sands lies a path, from retreat to resistance and revival. The 3 North Shelter Belt program began in 1978 and is one of China's largest, longest-running ecological restoration efforts. Aimed at halting desertification and protecting farmland, it has planted billions of trees and restored tens of millions of hectares, taming sandstorms and transforming regions over generations. Its value is quiet but profound: ecological security and improved quality of life. Beyond the projects above, China has world-class achievements in energy and science. For example, the Baihetan Hydropower Station is among the most complex hydropower hubs, with massive generating units manufactured and installed to micro and sub-millimeter tolerances, showcasing expertise in large-scale precision machinery. And FAST, the 500-meter aperture spherical telescope, sits in a karst sink and offers sensitivity multiple times that of earlier giant telescopes, used for exoplanet searches, pulsar studies, and dark matter research. Together, they illustrate China's integrated strength across energy, science, and infrastructure. These projects are no accident. They combine national planning, large engineering workforces, integrated supply chains, and sustained R&D. Unlike countries that stall on approvals, financing, or local disputes, China's system can concentrate resources and execute major projects quickly. China now exports this capability through overseas contracting and cooperation, reshaping parts of the global infrastructure landscape. Infrastructure is more than steel and concrete. It underpins national competitiveness, improves everyday life, and invests in the future. Over recent decades, China's engineering projects have reshaped geography, sped up economies, and broadened social possibilities. Have you ever looked around and noticed just how outdated some of our infrastructure has become? In the US, crumbling bridges and delayed trains are increasingly seen as just the way things are. According to the American Society of Civil Engineers, around 43% of all bridges in the country are over 50 years old. Many are even classified as structurally deficient. In 2023 alone, over 10,000 bridges were built or rebuilt, some of them world-class megastructures that span entire seas. The contrast in transportation infrastructure is even more striking. In New York City, the subway averages just 16 kilometers, and delays caused by aging equipment are a daily occurrence. Meanwhile, China's high-speed rail network races ahead at 356 kilometers per hour, with a total length exceeding 45,000 kilometers, accounting for more than 70% of the world's high-speed rail mileage. Take California's high-speed rail as an example. After 15 years of planning and debate, only a 190-kilometer stretch has been completed, with costs ballooning from $33 billion to over $128 billion. In contrast, China builds comparable rail lines in 40% less time and at 30% lower cost, without compromising quality or safety. The gap is just as visible in energy infrastructure. In parts of the U.S., aging power grids struggle to withstand extreme weather, often resulting in widespread blackouts. Meanwhile, China has built the world's largest clean energy system. Just one facility, the Baihetan Hydropower Station, can supply electricity to over 40 million households. While the U.S. is still debating pipeline repairs, China has already completed thousands of kilometers of natural gas and oil pipelines, meeting the world's highest technical and construction standards. Behind these numbers lies a fundamental difference in development models. In the U.S., infrastructure projects often stall amid lengthy approval processes and political gridlock. In China, powerful coordination, homegrown engineering innovation, and a long-term vision turn blueprints into reality at scale and speed. Want to know how these engineering miracles come to life? Let's dive into the construction front lines of some of China's most awe-inspiring projects, like the Deep Earth Tacor 1, the Shenzhen High-Speed Railway Tunnel, and the Changtai Yangtze River Bridge, and see what the future of infrastructure really looks like. In today's global infrastructure landscape, China is redefining what's possible, building at a speed and scale that is simply breathtaking. While many nations struggle to repair or upgrade aging infrastructure, China has launched a sweeping infrastructure revolution, reshaping geography and transforming lives through one mega project after another. In the remote Tarim basin of Xinjiang, the roar of drilling machines never stops at the Deep Earth Taklamakan 1 well. This is no ordinary project. It's a direct challenge to the Earth's limits. While shale gas drilling in the United States hovers around 3,000 meters, Chinese engineers, using an entirely domestically developed automated rig, have pushed the drill bit to a staggering 1,910 meters below ground. This makes the Taklamakan 1 well the deepest in Asia and the second deepest scientific borehole in the world. It also marks a historic breakthrough in China's deep earth exploration capabilities. Engineers faced extreme heat, pressure, and complex geological formations, yet they overcame these with relentless innovation. Every meter drilled pushed the boundaries of what humans can achieve. It is said that after drilling 9,000 meters underground at the Deep Earth Tacor 1 well, Chinese engineers broke through rock layers that date back 500 million years. They then converted seismic waveforms from 9,000 to 14,000 meters below the surface into audible frequencies, allowing us to hear the sounds from deep within the Earth. Meanwhile, under the Pearl River estuary, the construction of the Shenzhen high-speed railway tunnel is just as intense. At a depth of 106 meters beneath the seabed, the massive Shenzhen tunnel boring machine is advancing at a steady 15 meters per day. This project has already broken records, becoming the deepest shield tunneling project in the world for high-speed rail. While New York's century-old subway tunnels often experience delays due to aging infrastructure, China has reached a 100% localization rate for TBM technology. From design and manufacturing to deployment, every step is domestically driven. This tunnel not only broke depth records, but also set 5 global engineering benchmarks, including breakthroughs in cable imaging and tailpipe grouting. These advances have significantly improved construction efficiency, safety, and reliability. Even the New York Times couldn't help but express amazement. In the Pearl River estuary, Chinese engineers connected 6.7 kilometers of undersea tunnel segments with a margin of error of just 3 millimeters, like assembling the Lego blocks in the middle of the Pacific Ocean. Meanwhile, Boston's Big Dig overran its budget by 220% and resulted in a fatal ceiling collapse. Now shift your view to the Yangtze River, where the Changtai-Yangtze River Bridge is rewriting engineering history. Its 350-meter-tall cable-stayed tower, equal to a 115-story building, is now the tallest of its kind in the world. But it's not just the height that impresses. The bridge's innovative flat-deck design integrates high-speed rail, expressways, and local roads all on a single level, maximizing efficiency and minimizing land use. The main waterway bridge of this river-crossing channel is a cable-stayed bridge with a main span of 1,176 meters. While both Tianxingzhou Channel Bridge and Luanzhou Channel Bridge use a steel truss arch bridge with a main span of 388 meters. Its average area is approximately 5,400 square meters, which is the size of 13 basketball courts. The underwater foundation for the tower piers of the bridge uses 23,000 tons of steel. That's the steel of 3 Eiffel Towers. Engineers faced enormous challenges, such as maintaining vertical precision for ultra-tall towers and hoisting enormous steel beams across vast spans. Yet, through cutting-edge techniques and bold innovation, these obstacles were conquered. In stark contrast, California's high-speed rail project remains mired in cost overruns and technical delays. China, by comparison, is completing similar projects 40% faster and at 30% less cost, thanks to its powerful industrial base, streamlined coordination, and decades of accumulated engineering expertise. But these mega projects are just part of the picture. China's infrastructure miracle is also evident in its expanding transportation network. As of today, China's high-speed rail network has surpassed 25,000 miles, more than 70% of the global total. From the icy plains of Harbin to the tropical shores of Sanya, from coastal megacities like Shanghai to the high-altitude plateau of Lhasa, this network crisscrosses the country like a web of steel dragons, uniting cities and boosting regional economies. These rail lines have dramatically reduced travel times and improved quality of life, while also driving regional economic integration. Throughout the process, engineers have tackled an array of extreme challenges: Arctic cold, searing heat, fragile ecosystems, deserts, and more. For example, the Qinghai-Tibet Railway posed 3 world-class challenges: high-altitude hypoxia, permafrost, and environmental fragility. Chinese engineers responded with pioneering solutions like elevated bridges in place of roadbeds, ventilated stone foundations, and thermal stabilizing rods, ensuring the safe and sustainable operation of one of the most remarkable railways on Earth. China's bridge building capabilities are equally remarkable. Beyond the Changtai-Yangtze River Bridge, a growing list of world-class bridges continue to break records. For instance, the Beipanjiang Bridge, with a vertical clearance of 565.4 meters from deck to riverbed, holds the title of the world's highest bridge. The Huajang River Bridge, spanning 1,092 meters, is the world's first cable-stayed bridge combining both railway and highway functions with a span exceeding 1 kilometer. The construction of these bridges not only demonstrates China's world-leading expertise in bridge engineering, but also reflects the spirit of bold innovation and technical ambition among Chinese engineers. In these projects, China has adopted a variety of advanced structural designs such as suspension bridges, cable-stayed bridges, and arch bridges. It has also employed cutting-edge construction methods, including prefabricated assembly, incremental launching, and bridge rotation. These techniques have significantly improved construction efficiency and quality across the nation. Over the past 40 years, the rapid development of China's infrastructure has attracted attention from both domestic and international media. Some international reports, not intended as criticism, have referred to China as an infrastructure maniac. These reports express amazement at the scale, speed, difficulty, and advanced technology involved in certain infrastructure projects in China. But is China truly an infrastructure maniac? In other words, is China's approach to infrastructure development truly unique on the global stage? In this video, we will delve into the stories and technology behind these mega projects. Before we officially begin, be sure to subscribe and hit the bell so you don't miss any of our exciting content updates. We value your thoughts. Please share in the comments below which project amazes you the most. In the mountainous southwest of China, a colossal engineering marvel is redefining humanity's understanding of bridge construction. This is the Huajang Canyon Bridge. It's not only another masterpiece in China's Bridge Miracle series, but a new pinnacle in global bridge engineering. To better grasp its scale, the bridge deck rises 2,051 feet above the canyon floor, nearly as tall as the Shanghai Tower and nearly 600 feet taller than the Empire State Building. It's 9 times the height of the Golden Gate Bridge and twice as tall as the Eiffel Tower. This isn't exaggeration. It's the result of Chinese engineers relentlessly pushing boundaries. Once open to traffic, it will become one of the highest bridge decks in the world. Its main span reaches 4,658 feet, 32 feet longer than the UK's former world record Humber Bridge. The total length is a staggering 9,482 feet, an awe-inspiring feat. The bridge adopts a stiffened steel truss suspension structure, complex in form, yet highly stable and reliable. To support this extraordinary span, the design team implemented a cutting-edge rigid truss suspension system. The twin towers stand 859 and 672 feet tall, majestically anchoring each end of the canyon like modern industrial sculptures. Even in design aesthetics, engineers pay tribute to classic forms. The tiered connections at the tower tops that evoke the Art Deco flair of San Francisco's Golden Gate Bridge. But what truly commands respect is the difficulty of its construction. With the treacherous terrain of Huajang Canyon, engineers had to work at dizzying heights of over 2,050 feet to install massive steel trusses and main cables. Facing high winds and harsh lifting conditions, they relied on world-class construction technology and advanced simulation techniques to ensure precision at every step. The entire steel truss weighs 22,000 tons, yet all components were hoisted into place within just 2 months, a new benchmark for China's speed in bridge construction. According to Xinhua, the project cost approximately $283 million and was completed in just 42 months. Once operational, it will slash the canyon crossing commute from nearly an hour to just 1 minute, dramatically improving local transit and energizing regional economic growth. More importantly, the bridge integrates smart cable technology, with built-in sensors monitoring structural health in real time, ensuring long-term safety and stability. Today, this magnificent structure is not only a milestone in Chinese bridge history, but a rising global landmark. And it's sparked worldwide discussion online. An American netizen said, if this were in the US, it would probably never get done. No matter how big the budget, nobody would be willing to actually do the work. We used to be infrastructure maniacs too, but now we even rely on other countries to repair our warships. How ironic. A Brazilian viewer was clearly moved by the scale of the scene. This view is absolutely breathtaking. Standing on a bridge like this, I believe even the worst mood could be healed. A Vietnamese viewer commented, "What China is best at is turning the impossible into reality. Now I finally understand why they're called the infrastructure maniac." A German viewer said in disbelief, "This is unreal. The Chinese must have captured aliens to pull this off." I'm especially curious about what kind of material they use for those cables to handle such massive tension. The project even sparked some heated debate among viewers from Asian countries. A South Korean viewer questioned, "The Chinese just love to show off. Is it really necessary to build a bridge this tall? Feels like such a waste." But a Russian viewer clapped back immediately. "There's an old Chinese saying, if you want to get rich, build roads first. That's a kind of foresight some of you just wouldn't understand." An Italian viewer expressed admiration. "The Chinese are the people who built the Great Wall. I'm not surprised they can build something like this." Meanwhile, a British viewer focused on safety. "What I care about is whether it's earthquake-proof. That bridge is way too high. I wouldn't dare walk on it." A Canadian viewer added a dose of sarcasm. "In Ottawa, it took 5 guys 8 hours to fix a single manhole cover, and they were interviewed and even awarded for it. Now that's a reality check." Another German viewer chimed in, "I'm truly shocked by how fast they built it. If it were up to us, it might take 40 years, or 50. Of course, not all reactions were positive. A Japanese viewer claimed, "This is fake. There's no way the Chinese can build a bridge that tall. This must be CGI. China doesn't have that kind of technology." But that comment was quickly shot down by others. Have you been living under a rock? That bridge has already been built and opened. So what's your take on these global reactions? Were you blown away by this engineering marvel? Tell us your thoughts in the comments. And now let's continue watching. The birth of the Huajang Canyon Bridge is more than a technical triumph. It symbolizes China's ascent to the summit of global infrastructure. With breathtaking height and span and a pace and precision that defies convention, it declares to the world, China now stands unchallenged at the forefront of global megaproject engineering. But the Huajang Canyon Bridge is far from an isolated feat. In the very same mountains of Guizhou, a technological eye quietly gazes at the stars. It is the Chinese Sky Eye. This world's largest single-dish radio telescope boasts a 500-meter aperture, covering an area equivalent to 30 football fields. Nestled in a natural karst depression in Pingtang, Guizhou, it sits like a mirror of the sky, silently peering deep into the cosmos. The fast telescope's sensitivity is 2.5 times that of the now-retired Arecibo Observatory in the United States. It can detect the faintest electromagnetic signals from 13.7 billion light-years away, making it the most sensitive astronomical instrument ever built by humankind. Its applications range from exoplanet searches to dark matter studies, supporting gravitational wave follow-up observations. And it may one day be the first to pick up signals from extraterrestrial civilizations. To ensure that ultra-high sensitivity, engineers implemented an active surface deformation system. 4,450th individual panels can dynamically adjust their angles to track celestial targets. The entire structure is constructed with millimeter-level precision. No bolt is loose, demonstrating engineering control at its very limits. Further west in Guizhou, spanning the Jinsha River, the Baihetan Hydropower Station stands as another energy marvel, often dubbed the lung of the earth. One of the world's most complex and advanced hydropower stations, Baihetan boasts an installed capacity of 16 million kWh, second only to the Three Gorges Dam. It houses 16 turbine generator units, each rated at 1 million kWh. Remarkably, the 338-ton runner of each unit is manufactured and installed to an accuracy of just 0.02 mm, 1/5 the diameter of a human hair. What does that mean? It means these massive precision machines operate stably and efficiently under extreme heat, high water pressure, and turbulent flows. Their success is the crystallization of 30,000 hydropower standards and over 400 technological breakthroughs, integrating high-temperature insulation materials, superconducting generators, 3D fluid dynamics simulations, and more. Annually, Baihetan can replace 48 million tons of standard coal and cut 130 million tons of CO2 emissions, earning it praise as the pinnacle of clean energy. And the construction process of the Baihetan Hydropower Station is nothing short of breathtaking. Even American viewers, after watching how it was built, couldn't help but exclaim, "Honestly, this hydropower station is 3 centuries ahead of anything any other country can do. This is an epic-level project. Only China could have pulled this off." He went on, "If this were in the US, it would take us 50 years just to analyze it. Our government can't even fix a damn interstate highway. Are we sure China's engineering team isn't hiding aliens?" He was clearly fired up. "I'm telling you, at this rate, the Chinese might move the Atlantic Ocean to the moon just to make more room. Remember how they built an entire hospital in a week during COVID? This is nothing to them. I trust the quality, just like the Chinese products I buy every day, solid and reliable. China is making breakthroughs every single day." Comments like these are more than admiration. They're a recognition of China's unmatched capacity to plan, build, and deliver engineering miracles. This is China's infrastructure, shifting not just what's physically possible, but also how the world sees a rising nation. Imagine a 24-kilometer highway that slices through the sea, combining bridges, artificial islands, and a 5-kilometer underwater tunnel. This is the Shenzhen-Zhongshan Link, a masterpiece of daring engineering. Over 4,500 massive cargo ships pass through its shipping channels every day, yet traffic is never interrupted. Engineers didn't just build a bridge or a tunnel. They created a seamless connection beneath the waves. Steel, concrete, and precision engineering work together to conquer nature. This is more than infrastructure. It's the underwater highway that turns impossible into reality. Dalian Bay isn't friendly. Winters plunge to minus 22 degrees Celsius, threatening concrete curing. Yet China built its first cross-sea immersed tube tunnel in the freezing north. 3 kilometers of massive concrete boxes. Each immersed tube section is 165 meters long, 46 meters wide, and 10.6 meters high. If stood upright, it would be equivalent to a 55-meter tall building. Engineers floated them into place, sank them into the seabed trench, and pumped out the water to form a continuous roadway. This is not just construction. This is a battle with the elements, solved with innovation, precision, and relentless speed. An hour-long detour, now just 5 minutes through the tunnel. And just when you think that's unbelievable, China goes even deeper. 78 meters beneath the sea, under crushing water pressure, engineers are now boring a tunnel for high-speed trains at full speed. Meet the Gintong Undersea Tunnel, 16 kilometers long, with 11 kilometers running nonstop beneath the seabed. This is no longer transportation. This is humanity drilling straight through the planet. Every segment must withstand 7.8 atmospheres of pressure. One mistake could be catastrophic. 2 gigantic tunnel-boring machines, guided by lasers and satellites, carved through rock with millimeter precision. This is not just a tunnel. It's humanity rewriting the rules of engineering under the ocean. But China doesn't stop there, because the next tunnel isn't for trains at all. Welcome to the Yellow River Tunnel, the gigantic highway tube, not for rail, for cars, 17.5 meters in diameter, double-decker, 6 full lanes of non-stop traffic, rushing through the riverbed itself. China drilled through the Yellow River bed at record speed, 16 meters per day. The secret? A custom-built machine named Shanhe, devouring soft soil, installing concrete segments simultaneously. Incredible speed, extreme precision, and unfathomable scale. This tunnel transforms a massive river barrier into a 24/7 superhighway. This is the gigantic highway tube, where size, speed, and engineering collide. But China's engineering defiance of nature doesn't stop underground. Now, it goes vertical. Welcome to a battle between gravity and human ingenuity. The Three Gorges Dam ship lift, 3,000 tons, lifted 113 meters into the sky in just 40 minutes. No engines pushing it upward, only gravity, buoyancy, and pure mechanical genius. It's like stacking 30-story skyscrapers vertically and moving them in a single ride. Every mechanism is engineered to perfection. Every drop of water is harnessed. This is not a lock or a canal. This is the ultimate marriage of physics and human ingenuity. The ship lift shows what happens when you turn natural forces into precise engineering magic. But China didn't stop at lifting ships through mountains. Next, it lifted a bridge into the clouds, 625 meters above the river, nearly double the height of the Eiffel Tower. This is the Huajang Grand Canyon Bridge. Steel and concrete stretch across a bottomless gorge in Guizhou, suspended in thin air, defying gravity, cross winds, and raw geological chaos. Cars don't just cross a river here, they drive through the sky. This is not a bridge. This is a ribbon of steel stitched into the clouds. Engineers battled earthquakes, typhoons, and steep cliffs to create this sky ribbon. It's not just a bridge, it's a lifeline, transforming a dangerous mountain trek into a 2-minute drive. Every glance down is breathtaking. This is the sky ribbon, beauty and engineering fused. But the sky isn't finished yet. 3 megatowers rise into the clouds. The tallest one reaches 332 meters, higher than the Eiffel Tower. This is the Pingtang Bridge. From a distance, its structure bends light, shape, and perspective, forming a perfect halo in the mountains. They call it the cosmic eye, and it's not art, it's a bridge. Engineers had to stabilize foundations on karst limestone, navigate underground voids, and resist fierce winds. It's a bridge, yes, but also a piece of art. Functional, monumental, and visually hypnotic. The cosmic eye isn't just engineering, it's a vision turned reality. And just when you think bridge design can't get any crazier, China builds one that carries 3 worlds at once. High-speed rail, city traffic, and a full-scale expressway. This is the Changtai Yangtze River Bridge, the triple transport monster, a single structure carrying 3 different transportation systems simultaneously. And with this 3-in-1 design, an 80-minute journey between cities is crushed down to just 20 minutes. 3 layers of motion, 1 unstoppable river crossing. This is not just a bridge. This is transportation stacked in 3 dimensions. Asymmetrical decks, diamond-shaped towers, and multi-load balancing, all engineered to perfection. It's not just a bridge. It's a transport revolution, connecting communities and rewriting regional mobility. This is the triple transport monster of the Yangtze. And just when you think China's bridges have reached their limit, it builds one that dares the open sea, 35.7 kilometers across the Hangzhou Bay, one of the longest sea-crossing bridges on Earth, directly exposed to the fiercest typhoons in China. This is the Hangzhou Bay Bridge. Here, hurricane-force winds slam into the structure, walls of seawater crash against it day after day. So engineers turn the bridge itself into a living structure. The massive concrete piers are designed to withstand hurricane-level waves. And the bridge deck? It doesn't fight the storm, it flexes with it, absorbing the violence of wind and water like a living spine. This isn't just concrete and steel anymore. This is engineering that bends, breathes, and survives the ocean. And when the sea itself becomes the battlefield, China doesn't retreat. It builds power stations on the water. Hainan Offshore Wind Farm. Hundreds of floating turbines rising from the South China Sea, some towering over 200 meters tall. These aren't just windmills, they're power factories, generating electricity for millions of homes. Engineers battled super typhoons, crushing deep-sea currents, and the relentless corrosion of salt water to anchor these modern leviathans. This is renewable energy on a scale that feels impossible, but China did it. The ocean turbines show what happens when energy, scale, and daring collide. And from the open sea, the challenge shifts to something even more vertical. Chongqing Monorail. Suspended over steep canyons and threading through dense city streets, this monorail climbs hills at impossible angles. Curves, tunnels, and bridges twist through the skyline like a steel roller coaster. Every day, it carries hundreds of thousands of passengers, connecting neighborhoods where roads could never exist. The mountain climber proves that urban mobility can defy gravity, terrain, and expectation. And just when you think engineering can't climb any higher, it goes into the sky itself. Tibet Airport, the sky-high runway. At 4,274 meters above sea level, Ngari Airport is one of the highest airports on Earth. Engineers fought extreme altitude, freezing temperatures, and thin oxygen-starved air to lay a runway capable of handling full-size jet aircraft. Up here, engines lose power, human lungs struggle to breathe, and every single takeoff becomes a precision duel with physics. This is more than an airport. This is where engineering reaches into the clouds. The sky-high runway stretches human possibility to its absolute limit. And while some of China's boldest engineering reaches upward into the sky, another silent giant is being laid deep beneath the ocean. Under the South China Sea, a massive subsea fiber optic cable stretches hundreds of kilometers, connecting millions of users to the digital world in milliseconds. No planes, no bridges, just pure information, racing through the darkness at nearly the speed of light. China didn't stop there. It built mega data centers alongside it, each the size of a skyscraper, packed with servers, cooling systems, and AI infrastructure. This is where the internet meets engineering on a planetary scale. Every email, every video call, every online game could pass through this cable. It's not just infrastructure, it's the digital nervous system of a nation, built like a sci-fi fortress under the ocean. The internet backbone proves that China doesn't just connect cities, it connects the future. And there you have it, China's most insane jaw-dropping mega projects, each one bigger, faster, or wilder than anything you've ever imagined. From tunnels under the ocean to bridges that defy gravity, from airports that feel like spaceships to entire cities built from scratch, from energy grids that light up nations to robots running the world's biggest ports. These aren't just feats of engineering, they are a statement, a reminder that when humans push the limits, the impossible becomes reality. So the next time you think a project is too big, too crazy, or too dangerous, remember this: somewhere in China, engineers are already building it, bigger, faster, and more precise than anyone thought possible. US President Donald Trump has publicly acknowledged that America could never compete with China's infrastructure, expressing amazement at China's highways, bridges, and cutting-edge projects. He has mentioned China many times in public and has repeatedly expressed how much he loves the country.
Let's say China. And you know China, 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 South China, China, China. People say, oh, you don't like China. I like China. China. I love China. China. China all the time. China. When was the last time you heard?
But the question is, do these praises truly reflect reality? Has China really surpassed the West in technological innovation? Or is it all an illusion created by spectacular appearances? As people often say, seeing is believing. First, we'll take you to witness how China, through incredible feats of engineering, has built the world's longest undersea tunnel. This is a story you absolutely won't want to miss. Among China's countless mega projects that showcase its infrastructure prowess, the Shenzhen-Zhongshan link stands out as truly exceptional. Its scale and ambition are unprecedented, and though still under construction, it is destined to become a historic milestone in engineering. Stretching 24 kilometers across the heart of the Guangdong, Hong Kong, Macau Greater Bay Area, this colossal project integrates bridges, artificial islands, an undersea tunnel, and the world's first underwater interchange system. It will not only dramatically shorten travel time between the major economic hubs of Shenzhen and Zhongshan, but also demonstrate China's world-leading innovation in infrastructure development. So how has China managed to sustain such massive investments in infrastructure and do so with remarkable efficiency and creativity? Let's begin with this extraordinary case. In its design concept, the Shenzhen-Zhongshan link was created to ease congestion and build a direct connection between two powerhouse cities, Shenzhen and Zhongshan. Shenzhen, known as China's Silicon Valley, is a global technology hub and home to world-class giants like Huawei, Tencent, DJI, and BYD. From a humble fishing village, it has transformed into a modern metropolis of over 17 million people, leading China's charge in innovation and economic growth. Across the Pearl River estuary lies Zhongshan, one of China's key manufacturing and trade centers. Famous for its machinery, home appliances, and precision equipment industries, the city hosts more than 30,000 industrial enterprises. Yet despite their proximity, direct travel between Shenzhen and Zhongshan has long been a challenge, limited to the congested human bridge or slow ferry routes, often taking 2 to 3 hours each way. Once completed, the Shenzhen-Zhongshan link will cut that travel time to just 30 minutes, a game changer that will dramatically boost logistics efficiency, reduce transportation costs, and reshape the entire Greater Bay Area's economic integration. This mega project is unprecedented in both scale and complexity. Stretching 24 kilometers across the Pearl River Delta, it includes a 17-kilometer bridge system, 2 artificial islands as transition hubs, and a 6.7-kilometer underwater tunnel, one of the world's longest and most advanced immersed tube tunnels. Its most groundbreaking feature is the underwater interchange system, allowing vehicles to switch lanes directly beneath the sea, a first in human engineering history. The tunnel consists of 32 massive prefabricated concrete segments, each weighing over 80,000 tons, precisely aligned and joined on the seabed with millimeter-level accuracy. To withstand typhoons, earthquakes, and powerful currents, the entire structure employs triple-layer protection, anti-seismic, pressure-resistant, and watertight technologies. The artificial islands serve as vital operational hubs, housing emergency response centers, toll stations, and logistics facilities, further enhancing the corridor's strategic importance. To protect the fragile Pearl River estuary ecosystem, the project also integrates extensive noise reduction materials and eco-friendly construction techniques, minimizing the impact on rare marine species, including the endangered Chinese white dolphin. All of this reflects China's mastery in modern engineering, a symbol not only of construction speed, but also of the nation's achievements in technology, sustainability, and urban planning. At the heart of this project lies a true technological marvel, the 6.8-kilometer-long underwater tunnel, reaching depths of up to 40 meters below sea level. Designed as a dual 8-lane passage, its transport capacity far exceeds that of the Hong Kong-Zhuhai-Macau Bridge tunnel section. To ensure airtight, watertight, and earthquake-resistant joints under such immense underwater pressure, engineers used high-precision steel gaskets and flexible sealing materials, achieving what they call a vacuum-grade seal at every segment connection. Each standard immersed tube section is 165 meters long, 46 meters wide, and 10.6 meters high. If you stood it upright, it would be the height of a 55-story building, built with nearly 10,000 tons of steel. Each section requires about 29,000 cubic meters of concrete, enough to fill 12 Olympic-sized swimming pools. An intelligent robotic concreting system featuring automatic cycling, autonomous movement, automated control, and high-speed pouring ensures both quality and efficiency. Once a tube section is completed in the factory, it is installed using an advanced floating dock alignment system, achieving a connection accuracy of less than 2 millimeters. Inside the tunnel, an intelligent monitoring and ventilation system continuously tracks CO2 and particulate levels. It features HEPA-grade filters, longitudinal airflow control, and adaptive LED lighting that automatically adjusts brightness based on driving speed and external light, reducing driver fatigue and the risk of accidents. To ensure the structure endures for over a century, engineers developed a 5-layer anti-corrosion system inspired by shark skin. It includes an epoxy waterproof layer, a polyurethane shock absorption layer, a ceramic nanoware-resistant layer, a hydrophobic fluoropolymer coating, and a self-healing nanofilm. Additionally, 552 sacrificial anodes made of zinc aluminum alloy provide cathodic protection, actively attracting corrosive currents away from the main structure. The tunnel's exterior coating also features antibacterial and anti-fouling properties, preventing algae, barnacles, and microorganisms from attaching to its surface, keeping the tunnel clean and structurally stable beneath the sea. To achieve such extraordinary precision and durability, the entire manufacturing process took place inside China's self-developed AI Smart Dream Factory, a fully automated production base designed specifically for mega-scale infrastructure. In this climate-controlled facility, each 80,000-ton tunnel section is prefabricated with an accuracy within 0.02 millimeters, exceeding German industrial standards by 22%. Once completed, the massive segments are precisely moved by thousands of AI-controlled transport platforms, guided by GPS and laser navigation for exact positioning at sea. What once took 7 days of transport can now be completed in just 4 hours. Before installation, every single tunnel segment undergoes ultrasonic, X-ray, and magnetic field inspections to ensure there are no micro cracks or welding defects. Finally, the entire structure was subjected to extreme simulations, equivalent to 1,000 typhoons, magnitude 9 earthquakes, and even a projected sea level rise of 3 meters over the next century. The results showed its structural stability exceeded international standards by 83%. The Shenzhen-Zhongshan link is more than just a tunnel. It stands as a symbol of China's engineering and technological prowess, a fusion of automation, artificial intelligence, and green construction. It connects not only two cities, but also China's bold ambition to shape the future. And as the final segment of the Shenzhen-Zhongshan link locks into place, one thing becomes impossible to ignore. While the United States is still debating, China is still building. While Congress argues over budgets and repairs, China is cutting through oceans, mountains, and every limit engineering once had. This tunnel doesn't just connect two cities, it connects two eras. The era America used to lead, and the era China is defining now. Because when China decides to build, the world watches timelines collapse, records fall, and the impossible turn into daily routine. The Shenzhen-Zhongshan link is more than an engineering victory. It's a message. The race is no longer about who started first, but who's still moving forward. So the real question is, as China keeps pushing the boundaries of speed, scale, and ambition, will the US catch up? Or is this the moment the balance of global infrastructure leadership quietly shifts, once and for all? Thanks for watching, and buckle up, because the next mega project from China is already on the way. Deep in the mountains of China's Guizhou province, a new bridge has quietly risen, the Huajang Canyon Bridge. Before it ever opened to traffic, the structure was subjected to one of the most demanding load tests ever conducted on a bridge of its kind. 96 fully loaded trucks, a combined weight of over 3,700 tons, more than 400 sensors tracking stress, vibration, and structural behavior in real time. The purpose wasn't spectacle, it was verification, and the result wasn't just a pass. It was data that expanded the known limits of large-span bridge monitoring and safety assessment. This is not simply another record-breaking structure. It's a signal of where large-scale engineering experimentation is happening today, and how the focus of global infrastructure development is shifting in real time. So why can this bridge be seen as a true symbol of 21st century infrastructure? China is leading a once-in-a-century infrastructure transformation, building record-breaking mega projects at a pace rarely seen in modern history. Its national high-speed rail network now extends more than 26,000 kilometers, linking cities such as Beijing, Shanghai, Shenzhen, and Chengdu. It has become a global reference point for modernization and efficiency while laying the groundwork for long-term economic growth. In 2023, China's infrastructure investment approached $2.44 trillion, an 8% increase from the previous year. This reflects a strategic decision to position infrastructure as a central engine of economic expansion and international integration. These massive investments do more than expand global supply chains. They create opportunities for technological collaboration and innovation, strengthening China's role on the international stage. One striking example is the Huajang Grand Canyon Bridge in China's Guizhou province, a region long divided by rugged and inaccessible terrain. Scheduled to open in September 2025, the bridge spans 9,480 feet with a main span of 4,660 feet, reducing the crossing time over the canyon from 70 minutes to just 90 seconds. The Huajang Canyon Bridge is not only a transportation link, it also integrates a glass skywalk, bungee jumping, paragliding platforms, and cliffside walkways, positioning it as a new landmark tourist destination. Often compared to San Francisco's Golden Gate Bridge. Completed in just 3 years, the project showcases China's remarkable construction speed, its ability to overcome extreme geographic constraints, and its growing role in shaping the global infrastructure era. What makes this bridge truly astonishing is not only its scale, but its location and elevation. The Huajang Grand Canyon Bridge spans the Huajang Grand Canyon in Guizhou province, with a deck height reaching 625 meters above the canyon floor. To grasp this height intuitively, you would need to stand on the rooftop of Shanghai Tower, the tallest skyscraper in China, to reach a comparable elevation. Constructing a bridge at such an extreme height presented extraordinary challenges. Engineers had to contend with highly unstable mountainous terrain, as well as persistent and unpredictable high winds funneled through the canyon. Yet the objective remained singular and uncompromising: to bring the bridge into operation as early as possible, without compromising safety or structural integrity. And the height alone is not what makes this bridge remarkable. There is a saying in Guizhou: the land is never flat for 3 feet, and the sky is never clear for 3 days. This is not poetic exaggeration, but an accurate description of the region's geography and climate. More than 90% of Guizhou is covered by mountains and hills, and the Huajang Canyon lies at the heart of this terrain. The region is celebrated for its dramatic landscapes and cultural depth, earning it the nickname China's Switzerland. Internationally, it is recognized as a major destination for natural and cultural tourism. But beauty often comes at the cost of accessibility. For decades, Guizhou functioned almost like an inland island. Reaching the province was difficult, and traveling within it was even harder. This isolation is precisely why the Chinese government has invested tens of billions of dollars in infrastructure, seeking to fully integrate the region into the national transportation network and beyond. From the opening of Guiyang Longdongbao International Airport in the late 1990s to the expansion of high-speed rail and expressways across the province today, Guizhou's transportation map has been fundamentally reshaped. Yet construction is far from finished. Today, Guizhou is home to more than 32,000 bridges, one of the highest totals anywhere in the world. Built across some of the most complex terrain on Earth, these bridges provide direct, efficient routes where none previously existed. And among them, the Huajang Grand Canyon Bridge stands out as the most striking. Before its construction, China already held the record for the world's highest bridge with the Beipanjiang Bridge. The Huajang Bridge has now pushed that record even further. Its deck height reaches 2,051 feet, nearly 200 feet higher than the previous record holder. This is not merely a numerical increase. It represents a qualitative leap in the design and construction of long-span suspension bridges in deep canyon environments. Before the bridge existed, crossing from one side of the canyon to the other required a 2-hour journey along narrow, winding mountain roads. Today, the same crossing takes just 2 minutes. The Huajang Grand Canyon Bridge is a critical component of the SA-57 Guizhou-Qian Expressway, a roughly 150-kilometer route cutting directly through the mountainous interior of the province. To build this highway, engineers went so far as to carve a V-shaped corridor through solid rock, using explosives and heavy drilling equipment, effectively splitting an entire mountain to allow traffic to pass. The expressway connects Luji Special District with Anlong County, integrating 14 interchanges and bringing once isolated areas into the modern transportation network. Within this massive system, the Huajang Grand Canyon Bridge is the keystone. During site selection, engineers carried out detailed studies across a corridor stretching 5 to 10 kilometers on both sides of the canyon. They evaluated soil conditions at tower foundations, rock quality and extreme cliff heights, the required crossing width, wind behavior, seismic risk, and geological instability. After weighing all factors, one conclusion became unavoidable. Only a record-breaking suspension bridge could work. The bridge has a total length of 2,890 meters, with a main span of 1,420 meters. At this scale, the realistic options narrowed to cable-stayed or suspension designs. Engineers ultimately chose a steel truss suspension bridge, a proven and highly stable system for mountainous rock environments. The main cables are firmly anchored into solid bedrock, providing exceptional structural stability. Before construction began, engineers used virtual pre-assembly technology, digitally rehearsing the entire structure to ensure that every component could be installed accurately at extreme height. The steel truss consists of 93 segments, with a total steel weight of approximately 22,000 tons. For comparison, the Eiffel Tower contains about 7,300 tons of steel, meaning the Huajang Bridge uses nearly 3 times as much. All of this steel was installed 625 meters above the ground. At such heights, any falling component could cause catastrophic structural and economic loss. Precision became a matter of survival. Rather than relying on the world's tallest cranes, engineers adopted a more controlled strategy. Symmetrical construction from the center outward, maintaining balance and avoiding concentrated loads. Component positioning was guided by China's Beidou satellite navigation system, achieving centimeter-level accuracy.
What we have here is using what's called a cable crane, which is an overhead system. So it's like an overhead cable runway, where the units are delivered to the ends where you've already built the abutments and concrete foundations and so on. And then you lift it up and it travels along, almost like a monorail, but it's a cable, not a rail. And then you can deliver it to where it needs to be, and then you attach it to the cable system.
Because the terrain on either side of the canyon is asymmetrical, the bridge towers are different heights. The North Tower rises 262 meters, while the South Tower stands at approximately 205 meters. The cable system uses asymmetric anchoring to maintain overall stability.
The mountainside is anything but symmetrical. And so your 2 cables at the back coming down from the tower tops, coming down to ground where the anchorages are, will very often meet the ground at completely different levels or different places. So the asymmetry will be in the anchorages. Some might be deeper than the others, depending again on the local geology, exactly where the cable meets the ground.
Although Guizhou is not located in a major seismic zone, earthquake risk still exists. As a result, engineers incorporated hydraulic damping systems, similar to large-scale shock absorbers. These systems dissipate seismic energy while allowing the bridge to expand and contract naturally with temperature changes. Wind behavior in such a deep canyon is especially unpredictable. Due to the Venturi effect, wind speeds accelerate dramatically in narrow sections of the gorge, with gusts sometimes approaching the speed of high-speed trains. Engineers relied not only on computational simulations, but also conducted extensive wind tunnel testing, using scaled physical models of the bridge and canyon environment. In addition, the bridge is equipped with Doppler LiDAR systems to monitor wind speed and airflow patterns in real time. So what exactly is Doppler laser?
Doppler is a a system which we know from most familiarly. When a siren goes past you, the pitch changes, and that's just the frequency shift when something's moving. LiDAR is a way, it's a laser system for representing in three-dimensional space surfaces or voids, objects. And so what this is doing is using a sort of scatter of laser beams into the clouds, into the air, and measuring the frequency shift, the Doppler bit, measuring the frequency shift of the reflected signal. The signal is reflecting off moisture particles in the air. So what that's doing is building up a three-dimensional image of the moving moisture particles in the sky. And that gives you a picture of what the wind is doing.
Monitoring will continue long after construction is complete. Fiber optic sensors embedded within the main cables continuously track tension, strain, and vibration. Changes in light signals allow engineers to determine structural health with extreme precision. For a suspension bridge, the cables are the lifeline. The Huajang Grand Canyon Bridge is not only an engineering achievement, it has been designed as a comprehensive tourism destination. The bridge features an 800-meter glass elevator leading to a double-level cafe inside the tower, glass walkways overlooking the canyon, one of the world's highest bungee jumping platforms, large artificial waterfalls, and extreme sports facilities. The bridge itself is the destination. With a total cost of approximately $280 million, the project was completed, from groundbreaking to full-scale load testing, in just over 3 years. During the August 2025 load test, 96 trucks weighing a combined 3,700 tons were positioned on the bridge, while more than 400 sensors recorded real-time data. The results met the most stringent international safety standards. Media outlets from the United Kingdom, India, and the United Arab Emirates have described it as the bridge with the highest deck elevation in the world and as a defining symbol of China's modern infrastructure capability. By reducing crossing time from 70 minutes to 90 seconds, the Huajang Grand Canyon Bridge eliminates dangerous mountain roads, improves logistics efficiency, and lowers transportation costs. More importantly, it has become a key driver of balanced, inclusive, and sustainable development in Guizhou and across southwest China. The Huajang Grand Canyon Bridge is not merely a holder of world records. It is proof that China is redefining the limits of engineering in extreme environments, and a clear demonstration of how modern infrastructure can transform the destiny of an entire region. And in the end, the Huajang Grand Canyon Bridge is not really about height. It's about what happens when engineering confronts geography head-on and refuses to accept isolation as destiny. For centuries, terrain defined what was possible here. Mountains slowed movement. Canyons divided communities. Distance shaped opportunity. This bridge changes that equation, not by erasing the landscape, but by adapting to it, working with gravity, wind, rock, and uncertainty instead of trying to dominate them. That is what modern infrastructure looks like at its best. Not spectacle for its own sake, but systems designed to endure, to connect, and to quietly reshape lives long after construction crews have gone. Whether this model becomes a blueprint for the future or a cautionary reference will be debated for decades. But one thing is already certain. In places where geography once said no, engineering has learned to ask a different question: what if we build anyway? And as China continues to test that question across mountains, oceans, and fault lines, the rest of the world is watching. Not because these projects are the biggest, but because they force us to reconsider what infrastructure can mean in the 21st century. Thank you for watching. See you in the next video.